My name is Panos Zarogiannis. I'm the leader of ECHA's Drinking Water Directive team, and I will be chairing this two-day event. Welcome, everyone. Thank you for joining us today. This event was supposed to be a hybrid event with some people being on site, other people being online. However, due to the limited interest in physical participation, the event was changed to an online-only format. Now, this event is being live streamed with some technical issues, but watch these sessions directly from the event page. There are streams available, one for day 1 and another for day 2. Day 1 is today. These streams are hosted on YouTube, and you can view this there as well. After the event, the recordings will remain available on YouTube and on the event webpage, allowing you to revisit the sessions if you wish to review specific topics or focus more closely on certain details. We have a lot of material to cover today. In some parts, we may have to move quite quickly. While we hope this will not be happening too often, the recordings will be available to support you if you need to go back and review anything at your own pace. We invite participants to submit questions using the Slido platform, and we will continue to use Slido throughout today and tomorrow. There's a Slido widget on the event page on our webpage, and you can also access it by scanning the QR code that is shown on this slide and many other slides that are coming along. We encourage all participants to be active. Please try to focus your questions primarily, if not exclusively, on Euclid today. This event is specifically dedicated to Euclid, and we would prefer to avoid more general questions that fall outside that scope. There will be dedicated question and answers Q&A sessions, one at the end of today and 2 separate sessions scheduled for day 2. After the event, we will upload the slides used during the presentations. However, as there will be several live demonstrations, the video recordings will be particularly useful to you. Written responses to the submitted questions will also be uploaded after the event. This process of generating written answers could take a bit of time, as we need to review the questions carefully, perhaps seek clarification from the persons who ask the questions, and then also discuss the responses internally to ensure a consistent and accurate position. I would also like to be transparent. In some cases, answers may be given live during the event and may be incomplete due to time constraints. The written Q&A responses will ensure that the information provided to you is as accurate and reliable as possible. We strongly encourage you to consult them once they are published. Moving to the next slide, what are the aims for this workshop? The primary objective of this workshop is to demonstrate how Euclid can be used in practice. Our focus will be on the Drinking Water Directive specific working contexts in Euclid. We will concentrate on particular sections of the Euclid template relevant to this context. We will not cover all sections of Euclid today. Some of them are less critical, and others are maybe already familiar to many of you from other regulatory contexts, from REACH, for example, or the biocidal products regulation. We also cannot fit the entire Euclid in a two-day event. For these reasons, we will focus on what is new or particularly important for the Drinking Water Directive. We will also present support materials that are available, and some of them are still being developed, to assist applicants in preparing applications. Another key goal is to collect and address your questions. We want to better understand the technical challenges that applicants are facing using Euclid and assess the level of preparedness and awareness. Your questions help us understand whether users are still dealing with basic issues or have progressed to more complex aspects of their Euclid-based applications. Finally, we want to clarify the timelines involved and highlight that preparing a Euclid application dossier can be complex. We strongly encourage all interested stakeholders to engage with the process as early as possible, so that when the time comes to submit an application, they are prepared to submit a high-quality dossier. Now, there is a program for the two-day event on the event page. I will encourage you to download or at least have access to it to see also the timings of the different sections of parts, agenda points for this event. Specifically today, we will cover general aspects of Euclid and how it is used for applications under the Drinking Water Directive. We will also refer to the recently released Euclid application manual. Practical demonstrations today will cover the dossier header, intended uses, substance identity, and electrochemical testing for metallic compositions demonstrated to be passive. This final topic is slightly out of sequence, but due to the time required for it, it was more practical to include it today rather than tomorrow. Tomorrow, 2nd of June, we will demonstrate how to prepare section 5.1 with the migration of potentially relevant chemical species and the identification of relevant chemical species, analytical methods, which is section 6, section 7, which is toxicological data, and risk acceptance in Euclid section 8. We will also briefly cover additional important aspects of Euclid, such as validation rules, dissemination preview, timelines, and other practical considerations. We hope that what we will be presenting today will be useful and it will be placed in the correct context for those who are preparing or are about to start preparing applications for Drinking Water Directive applications. However, it is possible that some of you may not be very familiar with the processes. You may not understand more basic concepts, so you need to go a few steps back. My suggestion would be to make a start from a Drinking Water Directive infographic, which is published on the ECHA website and for which a link is provided on the slide. This infographic helps you understand from the very beginning what is the Drinking Water Directive European Positive List, whether it affects you, whether you should care about it, and then opens the door to all the steps you need to follow in order to make a successful submission. So you need to understand how to create an ECHA account, how to prepare a notification of intention, how to submit the notification of intention through the industry portal, how to start preparing for your application, which has much greater information requirements and requires much more effort and time compared to the notification of intention, and how, again, to access the relevant portal, the industry portal in most cases, to submit the application. What we're presenting today is vitally important, but it's somewhere, let's call it, in the middle of all this process. If you're willing to step back and start from an earlier step, please go to the infographic, and obviously you can come back to the recordings of today's event, and that will be perhaps a little bit more in context. Please also visit the page of the event we held in October last year, and that was another workshop, and there is a link for this on the slide. At that event, we present the process of creating an ECHA account, generating the notification of intention in Euclid, and then submitting the notification to ECHA. Recordings of our presentations and demonstrations from that event are available. Of course, you are very much encouraged to explore and discover those earlier steps. If you are planning to submit an application, though, in 2027, you need to start preparation of your application very soon. So without further delay, let's get started. Let's go into the first proper presentation of the day. Thank you again for being here. Please stay active and engaged. Send your questions using Slido, and if we're not able to answer any of them, we will be able to provide a written response. And I will continue to the next part of the agenda about the basics of Euclid software. If you give me a moment to organize myself. Right. This first presentation will cover two areas: the basics of the Euclid software and the latest changes to the Euclid template, the relevant Euclid working context in the version of Euclid that was released at the end of April this year. First, we will look at the basics. We will not spend too much time on this because we already covered this in the presentations we made at the event in October last year. That workshop provides additional background information. Videos of the presentations and live demonstrations are available, and you will find much more at the event page. If you are completely new to Euclid, you may need to start from an earlier step, as I mentioned earlier, than compared to other applicants. In that case, please begin with the introductory information I have already discussed in one of the previous slides. Right, what is Euclid? Euclid is an acronym that stands for International Uniform Chemical Information Database. It is a software tool used to prepare notifications of intention and applications under the Drinking Water Directive. Euclid contains formats which are made up of documents, often called records, and we may interchangeably use this term document and record today. These records are included in your Euclid submission to ECHA. You can think of Euclid as a package that contains several documents or records. Each record may include individual fields, pick lists and tick boxes, text and numerical fields, sometimes repeatable blocks of text, of fields. The exact structure depends on the information you are required to provide. Overall, the format is designed to store and organize data in a logical way, aligned as possible with the regulatory information requirements. Euclid includes important tools like the validation assistant and the dissemination preview, and we will take a look into them tomorrow towards the end of day 2. Finally, the outcome of the work you do in Euclid is a dossier, which is an I6Z file. This file contains all the data required for your submission, and then you need to use this to make your submission to ECHA using the relevant portal. In most cases, for economic operators at least, will be the industry portal. Right, so Euclid, you can use Euclid a number of ways. Euclid is available in the cloud. A trial version is available for 90 days to help you familiarize yourself with the software. And the full Euclid cloud allows you to prepare notifications and applications properly. The subscription expires after a period of inactivity, but it is not really a problem. You can subscribe again at any time, and your data remain private and not accessible by any other user. If you already have an ECHA account, you can log in immediately using the link that you can see on the screen. If you don't have an ECHA account yet, you can go still to the same place and try to register. And of course, to register, you need to provide some basic information like a username, password, an email address, and so forth. You can also install Euclid locally on your computer, but of course, please be aware that there are organizations where the IT departments may not allow you to, they may restrict local installations. This is something you need to investigate yourself as it applies on your specific case. Now, looking to the the very basics of creating a Euclid dossier for a Drinking Water Directive application, to submit a dossier via the relevant portal, you must create one or more datasets. In the Drinking Water Directive, a key difference compared to other regulatory contexts is that you may need several substance datasets for a single application. You always need one dataset for the applied for entry, for your starting substance, your organic cementitious constituent, the metallic composition, and so forth. But you may also need additional datasets for relevant chemical species. The data for the applied for entry forms the main structure of the dossier, starting from the dossier header all the way down to section 10. Additional datasets for potentially for relevant chemical species may be linked in the main dataset at its section 1.5. There will be a demonstration about this, and you will see how you link these additional datasets into the main dataset. It is important to understand the difference between dataset and dossier. A dataset is editable. You can add information, change information, remove information as you move forward, as you improve your knowledge or collect new information, or perhaps you receive information from somebody from a laboratory and so forth. A dossier, on the other hand, is a snapshot of your dataset at a specific point in time. You cannot edit a dossier. From the same dataset, at different points in time, you can create different dossiers. Okay, let's move to how to create a dataset. Again, these are very basic information, and we will not spend too much time on it. But effectively, when you enter Euclid, you will see the dashboard. It could be completely empty if it's your first visit to the dashboard. Then you need to click on the substances widget near the flask icon, and then the new substance orange button on the top right corner. You enter a name for your new substance. You can see an example, a fake example on the screen. Then you click the orange button to create the dataset. A confirmation message appears, and then you can open the newly created dataset and start adding information. In order to add information, you need to select the appropriate working context from the top left of the screen, because Euclid serves the needs of many different legislations, and the EU Drinking Water Directive is only one of those. So to create an application for the Drinking Water Directive, you need to go through the very long list you can see in the screenshot, and under the heading EU Drinking Water Directive, you need to select DWD application. Your substance dataset for the applied for entry is now created in the correct working context. You can now start adding documents, i.e. records. A plus button appears next to each section. I hope you can see the screenshot with the little red rectangle, the little hand that hovers over the plus icon. And that, if you click this, it will create a new document, for example, in the what you see in the screenshot in the section 1.2 composition. Now, as I mentioned already, Euclid fields include text and numeric fields, tables, images, tick boxes, drop-down menus. There is a variety. Euclid also uses dynamic content rules. That means that depending on selections you make at certain fields, the remaining fields in that document or record may appear, disappear, depending on whether they are relevant or irrelevant to the choice you have already made. A very typical example that will happen many times when you are preparing an application for the Drinking Water Directive is you are asked, what is the material type? Metallic, organic, cementitious, inorganic. Once you make a choice of material type, then a number of fields may disappear or appear depending on the choice you have made. So to summarize, you need to create data sets, you need to enter and edit the information in the data sets, you need to validate your information regularly, and we will explain tomorrow the role of the validation assistant. Then when you are ready, you can create your dossier. You download the dossier file as an I6Z file, and then you go to the relevant portal. For most of you, for economic operators, is industry portal, and then you log in to upload this I6Z file and make the submission of your dossier. Now, more information is available on our website and in the Euclid application manual, to which I will refer to in a moment in more detail. We will now move to more recent developments in the application templates. Yes, let's take a look at this. Some key changes have been made to the application templates for the Drinking Water Directive. Small changes have also been made to the template for notifications of intention, but we will not cover this aspect today because today's event is exclusively for applications. We will also take a look at the Euclid manuals for both processes, notification of intention and application. Right. Euclid 6 version 10 was released on the 27th of April. All three working contexts for the Drinking Water Directive have been updated, and that means the working context for application, notification of intention, and also data for relevant chemical species. Now, version 10 also includes the dissemination preview for Drinking Water Directive applications. Previously, that was only available for the notifications of intention. If you started creating your application using version 9, note that cloud users are usually updated automatically, but you must still check for changes and migrate your data if this is necessary. Now, using version 10, it is very strongly recommended for all applicants. Please use it in order to avoid any issues with your submissions. Now, let's move into the manuals briefly, and there will be some parts from those manuals presented in a later presentation. We have revised the manual for preparing notification of intention that was published on the 28th of April. Generally, the changes have been small because the changes to the template, the Euclid template, have been quite small as well. But most importantly, especially for today's event, is that we have issued on the 28th of April a Euclid manual for preparing DWD applications. This is a 260-page document, which is very extensive. You, of course, do not need to read it all, but it does provide step-by-step guidance covering creating a data set, how you address the fields in different Euclid sections, how to do the validation, how to deal with confidentiality and dissemination of your information. We will see in the next presentation a few more details about the manual. We do welcome feedback on these manuals, and we will continue to develop them as we develop the Euclid template, as we learn more, as we receive feedback from you. And if you wish to provide feedback, please get in touch. There is an email address at the very end of our presentation, both today and tomorrow. Or if you want to contact us, you can always try to contact us through the ECHA help desk. Now, there are a few slides before I finish this presentation about the key changes to the Euclid template that happened in April this year. This will not cover all the changes that have been made. You need to be aware that we have made a more detailed presentation on 22nd of May at the meeting of the Drinking Water Directive IT Tools user group. This is a user group that supports us with the development of Euclid, the manuals, and so forth. And we meet periodically to explain to the members of that user group what has changed and what we ask them to test and provide feedback on. The presentations from those events are being published on the link that you can see on the screen. I think they're not yet available, but very soon they will become available. So if you want to have a more detailed explanation of what has changed in April 2026, please visit that link to see the slides we used at that event. And of course, I think I will mention later on tomorrow actually that the IT Tools user group does accept new members if you want to join. So briefly for the different parts of Euclid, in the dossier header, we have made minor changes to labels and help text. And in sections 1.1 and 1.2, we have made some small adjustments. An important change has been made in section 1.5 because previously, if you needed to report multiple relevant chemical species, for example, impurities, degradation products, or constituents of a composition, let's assume copper, zinc, lead, aluminum from a metallic composition, you would need to create one document previously with repeatable blocks of fields to cover each one of these relevant chemical species. This approach is no longer valid. What you need to do now for IT and data handling reasons, you need to create separate documents, separate records for each relevant chemical species. So you have 5 relevant chemical species. In section 1.5 of the main dataset, you need to link to create 5 documents, 5 records for each of your relevant chemical species. We will see in a moment how this works. Section 2, which is GHS document, this has not really changed in the background, but what has changed is its presentation. This now has been tailored specifically to be limited to the needs of the Drinking Water Directive. So endpoints which are not relevant to Drinking Water Directive applications, for example, acute toxicity, irritation, most environmental endpoints, they have been hidden. So as a result, now you can focus on what you can see on the screen, which are what is relevant for Drinking Water Directive. In section 3, on physicochemical properties, the focus here was on melt flow index. This is a new physicochemical property in section 3.15, which is relevant only to polymers, to starting substances, which are only polymers and prepolymers and cementitious constituents. So starting substances and organic cementitious constituents, which are polymers and prepolymers. If this is of relevance to you, please take a look at the melt flow index because it has received significant improvements. Section 4 on intended uses has undergone substantial review and modification. The metallic material category pick lists have been updated, and now you have the option to modify an existing entry, an existing category. So if you want to still apply for copper zinc alloys, but you want to modify the ranges of the concentration ranges of the constituents, then you need to choose now modify existing category rather than choosing copper zinc alloys in my example. There is now a new field for proposed conditions of use for inclusion in the positive list. Here you can explain how you believe the substance should be listed and under what conditions of use. The Committee for Risk Assessment, RAC, will review this proposal and may agree, hopefully, or may disagree with it. New fields have also been added to demonstrate compliance with the rules on monomers and polymers, as described in Article 3, Paragraph 4 of Regulation 369 of 2024. Please make sure that you are familiar with those legal requirements, and detailed guidance on how to use these new fields is given in the Euclid application manual. Additional updates in Section 4 includes new fields for the dosage of starting substances and organic cementitious constituents, updated help texts, revised dynamic content rules, and more generally, Section 4 has been reviewed quite extensively. Moving on to Section 5.1 on migration. Now, this has also been extensively improved. We have added new fields for reference, data access, and data protection. There are new fields under the full transfer method. We have reordered certain fields, and we have updated pick list and help text. A major structural change concerns how migration test results are reported. Previously, results were reported using nested blocks of fields, which proved complex to use. These now have been replaced by one simple repeatable block. If you have used this section before, you should find the new structure much clearer and easier to use. Moving on to section 6 on analytical methods, this has also been improved visually. It is now a customized view of the analytical methods document showing only fields relevant to the Drinking Water Directive. Please be aware that this section is used to report analytical methods for screening studies, analysis of migration water to measure the potentially relevant chemical species, and analysis of test species, for example, to analyze the test species for a metallic composition that you are applying for. Moving to section 7, I'm almost coming to the end of this presentation. Very small changes here, but it is important to highlight that there are now two summary documents in section 7. One is the summary on genotoxicity hazard, focusing on your overall conclusion of genotoxicity. And then there is a summary document called toxicological information covering other relevant toxicological properties. Other than that, the overall structure of section 7 has remained largely unchanged. Now, I think that is probably my last slide for this presentation. I hope it is useful, this summary of what we have changed. Section 8 on risk acceptance has been modified quite extensively. Similar to section 1.5, previously you were able to use to create one record with repeat blocks of fields to report the risk acceptance of multiple relevant chemical species. This is no longer the case. In section 8, you need to create separate documents for each relevant chemical species. Additionally, we have now added a field to explain for which type of metallic composition you are applying for. Initially, you will see in a live demonstration, first you choose what is the material type. Once you say metallic composition, metallic materials, then you need to identify what type of metallic composition you are applying for, and this happens because the requirements for the different metallic compositions for risk acceptance are not always the same. And the three types of metallic compositions that are being covered now in section 8 is passive compositions, metallic compositions used exclusively for product group D, and all other metallic compositions, which is we expect to be the most common case. Now, you need to understand that the risk acceptance for these different types is different, as I already mentioned. For non-passive metallic compositions, such as brass alloys, you must now clearly show in section 8 how you meet the two risk acceptance criteria that are shown in Annex 6 to Decision 365 of 2024. The first risk acceptance criterion is that the CTAP value must be lower than the empty CTAP value starting week 16. And then the CTAP value must show a decreasing trend. Now there are places in this annex, this section 8, for you to provide this information much more clearly than before. You must also make a link to section 5.1 where you have demonstrated how this relevant species migrates. I will finish with section 9 and 10. They have received only small changes. And I will finish here. I hope this quick summary, which is fairly high level, has still given you some idea of what has changed and what changes to focus in case you have already started preparing an application and now perhaps you need to adjust the presentation of your data. Thank you for this. I will stay on the chair. Apologies for dealing with me a little bit longer. I will take a sip of water. And let's move to agenda point 3. Let's look into some important concepts which you need to be aware of and you need to use to your advantage in order to prepare a successful application for the Drinking Water Directive. What this presentation is going to cover is the types of data required in the Drinking Water Directive application, an explanation of key terms such as applied for entry, potentially relevant chemical species, and relevant chemical species. I will be presenting the Euclid working context for Drinking Water Directive applications. We have already really touched upon them a little bit. I will explain how many datasets you should aim to generate in order to create your dossier that you will be submitting to us at ECHA. And finally, there will be a live demonstration of how you can combine multiple datasets into a single dossier through section 1.5 of the main dataset. So first, let's take a look at what types of data are required in Drinking Water Directive application. Now, you will see on the screen on a high-level overview of the requirements as they're being set out in the annex to Regulation 369 of 2024. This is a relatively simple list, just a snapshot at the high level of what is required. The first requirement is that you need to identify yourself or any representative you are using to make the application, and previously you may have done this for the notification of intention as well. But to be absolutely clear, this information is not provided in Euclid. This is provided in the submission portal, the industry portal that economic operators will be using. So we do need this information, but it's not really something that you should aim to provide in Euclid. The second requirement, which is relevant to Euclid, is the identification of what you're applying for, your starting substance, the composition, or the organic cementitious constituent. Then you must describe the intended uses of what you're applying for. You need to provide information on the physicochemical properties of your substance or composition. And in some cases, for relevant chemical species, you may also need to provide a smaller volume of physicochemical information for the so-called non-intentionally added species, which also happen to be relevant chemical species. Next, you need to provide migration data. In a limited number of cases, physical migration testing may be replaced by migration modeling. You then need to identify the species which are relevant to toxicological testing and risk assessment. These are the so-called relevant chemical species. And for this, obviously, you need to provide, as I mentioned, toxicological properties and do the risk acceptance as it is prescribed in the annexes of Decision 365 of 2024. Finally, you should always be aware of the conditions set out in these annexes, on the annexes of this commission decision, because under certain circumstances, some information requirements may be waived or be reduced. Please be very clear on what the requirements in the annexes of this decision are. Right, here is where I'm making provide some information from the Euclid application manual that was recently published, and I would like to highlight this table 1 of that comes from the manual. This table provides a mapping between the legal information requirements, the structure of the Euclid format, and the corresponding guidance available. The slide you see now shows only a small snapshot because the table in the manual spans several pages, so it is not possible to display all of it. However, in the table, you will see that the information requirements are grouped by annex in Decision 365 of 2024. The middle column shows the specific Euclid sections where you need to address that information requirement. Next to it on the right, you have clickable links to the relevant guidance documents, an indication of which section or sections are relevant. And finally, there's a notes column where it shows you, gives you some useful background, sometimes indicates which material type is relevant or not relevant to a specific information requirement. I would recommend that you do take the time to go through this table. It's very useful. And please make yourself familiar with it. The reality is that Euclid predates the Drinking Water Directive and aims to support the needs of multiple regulatory contexts. So therefore, it is not always possible Euclid to completely match the legal text, and that's why we do need this type of mapping. And I hope you will find this mapping table particularly useful to guide you where to do what in Euclid. The next topic I'm going to cover is 3 important terms that we will be using today and tomorrow, and obviously they're also in the Euclid manual. The terms you see on the screen: applied for entry, potentially relevant chemical species, and relevant chemical species. Now, the applied for entry is just an umbrella term. It refers to the subject of your application, what you're applying for. It could be a starting substance for organic materials, it could be an organic cementitious constituent, or it could be a metallic or inorganic composition. What you want to put to place or keep on the European positive list. Now, we just use this term so we don't constantly have to refer to starting substance, composition, and constituent. Applied for entry is what you're applying for. The second term is potentially relevant chemical species. This refers to any chemical entity that may end up in drinking water as a result of the use of the applied for entry. At this stage, the chemical species may or may not ultimately be relevant. We will determine this later. But potentially relevant chemical species may include the starting substance or organic cementitious constituent itself, substance additives, constituents of multi-constituent substances, impurities, reaction products, hydrolysis products, many different things. To establish the list of potentially relevant chemical species that you need to investigate, you need to understand the identity of the applied for entry, its impurities and constituents, its intended uses, the manufacture and other processes involved, and possible reactions during use. In many cases, the assessment will be straightforward. In other cases, it may be complex and it must be clearly explained in your application because these are the chemical species that you need to evaluate the migration of. From the potentially relevant chemical species, we go to the relevant chemical species. This is effectively a subset. And these are the most important because, as it was mentioned earlier, it's the ones that for which you need to perform toxicological assessment and human health risk assessment. For metallic and inorganic compositions, there is no separate concept between potentially relevant and relevant chemical species. Why? Because Section 1.4 of Annex 4 to Commission Decision 365 of 2024 clearly specifies which elements are or are not relevant. This means you can immediately determine, for example, that certain elements, take silicon in the case of it being an impurity in an alloy, is not a relevant chemical species. You know this from the beginning. You do not really need to do an investigation. On the contrary, for organic and cementitious materials, relevant chemical species are identified based on criteria such as the migration and whether this happens at a concentration with a concentration that the CTAP value is above 0.1 microns per liter, the hazard classification of the potentially relevant chemical species, if it's a CMR category 1A or 1B, for instance, or the use of the substance as a monomer in the manufacture of polymers, since monomers are always considered relevant chemical species. It is important to note that metallic and inorganic compositions themselves are never relevant chemical species. These are just special mixtures. Only their constituents and impurities may be or may not be relevant chemical species. Now, please, before we move on, please consider the suggestion made at the bottom of the slide. Section 3 of Annex 4 to Decision 365 of 2024 explains what should be the approach to identifying the relevant chemical species for the different material types. Please be very familiar with this part of the legislation. Let's move now to the EUCLID working context for drinking water directives. I think I touched upon this a little bit earlier, and there was a similar, if not the same, screenshot. What is a working context? A working context provides a specific table of contents, and it is a visual and structural framework for managing data for a particular regulatory context that is served by EUCLID. So in the case of a drinking water directive, we have three working contexts. One is for the notification of intention, and we will not cover it at all today or tomorrow. Then there is a drinking water directive application. You can see in the screenshot this is the DWD application. And the third one is the DWD data for relevant chemical species. As I mentioned before, the application working context contains 10 sections plus the dossier header. The relevant chemical species working context has fewer sections and contains no dossier header. When creating a dataset, you need to be careful and select the correct working context. If you are working on your applied for entry, your starting substance, your alloy, your enamel, ceramic, or your organic cementitious constituent, you do need to use DWD application as your working context. If you want to create a dataset for a relevant chemical species, an impurity, for example, that is also released to the water while you're using your starting substance, then you need to use the DWD data for relevant chemical species working context. Here is another screenshot from a table 2 from the EUCLID application manual. I will not go through this in detail, and it's only just one screenshot from one page, and the table, I think it takes a couple of pages. Here you can see in the manual which parts of Euclid, which section of Euclid are relevant to the two working contexts that you may have to use in order to submit, to create a dossier and submit your dossier for your Drinking Water Directive application. You will see, for example, as I mentioned before, dossier header is relevant to the DWD application, but not to the DWD data for relevant chemical species working context. Now, let's take a look at how many datasets you need in order to generate the application dossier. As I mentioned already, unlike other regulatory processes, Drinking Water Directive may require more than one dataset within the same dossier. One dossier, multiple datasets. You always need a dataset for the applied for entry. Irrespective of the material type, you do need a dataset. But also you may need zero, I mean, you mean nothing, or you may need 1 or 2 or 5 or potentially 20 or more datasets for relevant chemical species. The number depends entirely on your case. In some applications could be substantially high. The application manual provides some examples to help you understand this concept, and it gives an example of a starting substance or organic cementitious constituent with 2 impurities, and there the dossier needs to be based on 1 plus 2 datasets, 1 for the starting substance plus 2 datasets for the 2 impurities. In the case of a metallic, enamel, ceramic, or other inorganic composition, the example here in the manual is that we have 3 relevant chemical species, copper, zinc, lead, for instance. Then you need 1 dataset for the alloy or the ceramic or the enamel, plus 3 datasets for the 3 relevant chemical species. Certain information must always be presented in the dataset of the applied for entry, what sometimes I may call the main dataset, and that covers all relevant chemical species. It's for the entire application. So the dossier header is there only for the main dataset. The intended uses in section 4 is only in the dataset of the applied for entry. Migration data for all potentially relevant chemical species are in section 5 of the main dataset. Analytical methods for migration and material characterization, again in the main dataset, and risk acceptance in section 8, again in the main dataset. Some other information is chemical species specific, and it is presented in the corresponding dataset. You may have a classification for your impurity, for example. You will have to provide something in section 2 of the relevant dataset. Physicochemical data required in some cases a small amount actually for non-intentionally added species. You may add them in section 3 of the relevant dataset. The same with toxicological data, and the same with report section 10 in case you need to report something in the some report that we cannot really include in any other place in the dossier. Something is missing from this from the list. Actually, also section 9 is chemical species specific. So when it comes to assessment by authorities, you may also need to provide something specifically in the dataset of the relevant chemical species. Then moving on to another screenshot of from the manual, the application manual. This is table 3. I will not go through this in detail. I think that actually I have 2 slides for this to cover the entire table on this occasion, but we will not, in the interest of time, I will not go through it in detail. Please take a look at this table. It explains for these examples, I have already mentioned this starting substance with 2 impurities or a metallic composition with 3 relevant chemical species. It explains which working context to be used in each case and what are the contents for each working context. In red, you will see which parts are not relevant for relevant chemical species. Please do take a look. One important point perhaps to point out is that for physicochemical properties, in section 3 of for a starting substance or organic cementitious constituent, you need to provide quite a significant number of information for a significant number of physicochemical properties, and this number is even higher if you need if you are dealing with a polymer or prepolymer. For an relevant chemical species for organic or cementitious materials, in section 3 of the relevant data sets of the relevant chemical species, you need to provide a little bit of information on the water solubility and the lockout, the octanol water partition coefficient, but you do need to provide something. If I move now to the metallic and inorganic compositions, there is a small number of physicochemical properties that need to be addressed in the applied for entry dataset, the main dataset, and there is no need, there is no requirement for any physicochemical properties for relevant chemical species. So do not provide any physicochemical properties for copper, titanium, molybdenum, or whatever is being released from a metallic or inorganic composition. And this is the second slide with the second part of the same table. I will skip it, but please, is the proper way of looking into this open the Euclid application manual and go through it to understand what applies in your specific case. So how do I combine all these data sets? I may have 1, 2, 3, 5 for different relevant chemical species. How do I make them come together into a single dossier? I have mentioned briefly earlier, and I will demonstrate in a moment, how you actually link them in section 1.5 of the main data set. I think we can go now to the live demonstration. If you give me 1 second to see, we have a Euclid account which sometimes is not working because of the period of inactivity. I think it does work now, and I think the font size is too big. I think this should be enough. Let's see how this works. Yes, I hope you can now see my screen. This is a dataset I developed just for the purpose of demonstration. Obviously, you can see it's mostly empty. I can move my mouse to the relevant screen. Yes, it's here. Okay, so what I have done is that I have created this dataset. I have used the DWD application working context from up here. I hope you can see it on the top left of my screen. So it is the correct working context. The table of contents is, as I mentioned, from the dossier header, which is up here where I'm hovering my little hand, all the way down to section 10 reports. The relevant section is section 1.5. And I have created 2 records here to demonstrate how this works. One is for organic materials, the other is for metallic materials. Essentially, I'm covering all material types by making you this demonstration. Organic and cementitious is really very similar. Inorganics is also very similar. Metallics is only marginally different, but essentially you will see it's not really it does not really affect the material type doesn't really have too much of an influence. Only in a small place that I will explain. To be absolutely clear, you are not expected. You should not indeed try to cover more than one material type in the same application. If you have a substance which is used in organic and cementitious materials, for example, you must make separate applications. Here is just a demonstration, and I'm going to show you what it looks like. So I have 2 documents. One is for ethanol, which I treat as a relevant chemical species for my imaginary starting substance. And then I have a document for zinc, which is a constituent for an imaginary alloy. Before I go into this section 1.5 of the main dataset, I will show you the dataset of ethanol that I have created with obviously fake data to demonstrate this, how it works. I will go through my list of different datasets, and it is here. So what you immediately see by opening this dataset is that I have the correct working context, which is DWD data for relevant chemical species. And this is the correct context to use for relevant chemical species, as I have mentioned probably too many times already. The list of sections that you need to cover is much shorter. You see, goes 1, 2, 3, 7, 9, and 10. What you need to do is effectively go to the identification in section 1.1. You identify, obviously, your relevant chemical species. I called it, for ease of identification, ethanol RCS. You need to link a reference substance, ethanol, with its EC number, CAS numbers, and so forth. We're not going to reference substances, something very basic in Euclid. If you do not know this, please go into the Euclid manual to understand. And here in this field type of applied for entry / relevant chemical species, I must choose other from the pick list option. I can do that. It's pick list option other, and then after I select other, in the remarks field, which is where I'm highlighting now, you need to simply type relevant chemical species, and I will try to save. I look at the big screen ahead, that's why I'm leaning over a little bit. And this is basically what you need to do in section 1. Section 1.4, actually, we're planning to remove it from the this working context. You should not be giving analytical information for relevant chemical species. In section 2, you may need to provide classification. That is on a case-by-case basis, and as I mentioned before, we look into specific classification endpoints, not absolutely everything. Classification which is relevant to Drinking Water Directive. I will not open the document. It's a completely fake document. It's completely empty, but I have created one because I assume that I have classification for ethanol. In the case of section 3, you will see that the list of physicochemical properties you need to provide for a relevant chemical species for organic and cementitious materials is much shorter. I have water solubility and partition coefficient. In both cases, I have created 2 records and a summary record, here the one that has the sigma, the Greek sigma symbol in the orange dot, which summarize my conclusion. I have 2 water solubility documents. My overall conclusion in the summary document is that the water solubility is whatever I think it should be. So I need to provide information in this section 3. And finally, in the toxicological data, you will see that in my imaginary example, ethanol is migrating in the low migration tier. The toxicological information requirements are for genotoxicity, and therefore in the section 7.1 mutagenicity, I have created some records, something about mutagenicity in vitro. I have a record in mutagenicity in vivo. I have a summary document here under section 7.1, which is a summary of mutagenicity, and then there is the big summary on genotoxicity, which you need to present and under section 7. I'm not giving you obviously any content. That's not the point of the presentation. It's more for you to understand the correct working context. I will scroll up for you to see it again. It's from here, and to see also that the list of sections you need potential to fill in is much, much shorter. So I will go back now to my main data set, which was this one here, okay? So what do I need to do there? I have already done my dataset for ethanol separately with the correct working context. I'm going to section 1.5, and then I create this document. I will just recount my steps to see what I have done, although it is already pre-filled. The first field is the material type. I have chosen from a pick list of 4 options organic materials. And then there is this relevant chemical species other than the applied for entry block of fields, which I need to fill in. The first thing I do is to create a link to the relevant chemical species dataset. This is not a reference substance. This is the dataset. I can actually delete the link. It is actually a select box with a plus button. I selected, my different datasets appear. It is the one at the top of the list. I selected, the link has been made. The next field is to select the type of relevant chemical species. This is a nested pick list. So I can click on the blue button. I can see the two main options I have applied for entry or non-intentionally added species. I click them both to open for you to see the different options. In my case, I mentioned my example is an impurity. So I go under the NIAS menu, I select impurity, and this is it. I can add a remark here if I want to, like I have done. I can just like this to see for you to see how it works. The next field is the migration tier for the specific relevant chemical species. From the pick list of 3 options, low, medium, high, I select, in my example, it was low. And then there are 2 fields which are quite important. There are 2 fields where you declare whether you waive the physicochemical data or toxicological data. I have selected no in my case, but if I were to select yes, then a new field appears where I need to justify why I'm waiving physicochemical data. And if I click on this, there is a pick list where you can select 1 or more, but believe me, 1 is enough, and try to select just 1. It makes things so much easier. You need to select for what reason you are not providing physicochemical information. One example is you have an existing parametric value for this relevant chemical species in Annex 1 of the Drinking Water Directive. I could click on this if it was relevant to me. It was not, So I'll just delete it and I'll go back and make this option, no. And you see the justification field has disappeared. Similarly, for toxicological data, I can select yes or no. If I select yes, justification field appears, and then there is a possibility of choosing something. The options here overlap, but they are not the same as for the justification of the waiving of physicochemical properties. So be careful. Most logically, you may make the same selections in both pick lists for justifying the waiving, but be aware that the pick lists do not really match. I will make this a no, not to waive. And finally, remarks and attached document is fields that you may use if you feel necessary. I could not come up with any good examples, so I have left them empty. And this is basically it. And now I will press the save button. I have finished. Briefly, I will go through my example of zinc. I hope I'm in time reasonably well. Yes, let's go into zinc, which is, in my case, in my imaginary example, it's a constituent of an alloy. And I need to go here, obviously. Yes, so the first selection I make is the material type. I have chosen metallic materials from the pick list. Then I have made the link to the zinc dataset. I will go into that in a moment. You will see how sparsely populated it is. From another new pick list, which is unique now to metallic and inorganic compositions, I need to click. There's not this nested pick list, which we had applied for entry in IAS and whatever. I have either constituent or impurity. In my example, I select constituent. Then I need to select the migration tier. That, of course, information comes from the migration test results. And in my case, I have selected high. And then this is a fairly realistic example. There is a question about the toxicological data waiving. You will notice that there is no question for the physicochemical properties waiving. As I mentioned before, we do not need any physicochemical properties for relevant chemical species for metallic or inorganic composition. So we're ignoring them. But indeed, you may waive the toxicological properties. And I have selected from the pick list, yes or no, I have selected yes. And then there is a new, let me delete this and create, go back to the beginning. There is a possibility to select one or more. One is enough. Keep it simple. One is enough. You can select the reason for which you are waiving tox data. In this case, which is a real case, actually, I do have an SML that has been a specific migration limit that has been set under food contact materials legislation, and it is no older than 15 years compared to the date of the submission of my Drinking Water Directive application. We will come back to this tomorrow when we're discussing and presenting how to complete Section 8. So I select SML. I have added some remarks here, which I could obviously have added into this remarks field as well. So it doesn't matter. Perhaps I should have put it into this remarks field. But anyway, just for you to be shown how this works, the remarks field I have used is a free text field, and I have added some relevant information. The empty setup is based on existing SML value, which is no older than 15 years old, and so forth. This comes from the from Annex 6 to Decision 365 of 2024. As I mentioned before, be familiar with the waivers that are being allowed under the legislation, specifically the annexes of that Decision 365. I don't have any attachments here. I could attach something if I wanted to. I just select files, then I will browse my computer to find a relevant attachment. And something to finish with this presentation is how you actually go from this main data set into the linked data set. If you hover over zinc here, I hope you can see my little hand. I'm hovering over the word zinc, which is the reference substance. You can see it's on the reference substance is actually the data set. I was wrong to call it the reference substance. You can see on the right-hand side, a little bit further, as I'm moving my hand, there are two arrows pointing to the right. And this tells you there is a tooltip that appears and says go to subtree. If I click on this, oh yes, I live into, sorry, I need to save my work. I modified something and I confused, and yes, I saved it. Actually, I moved already to the dataset of zinc. Okay. Why they went back? It really this has not worked the way I expected. Give me 1 second. I need to go back. Okay, I was here. I was in the metallic materials example. Yes, zinc is here. You see the two little arrows to the right. I'm clicking on that. This takes me now properly to the dataset of zinc. Okay. In order to go back to my main dataset, I'm using these arrows point to the left, where I'm circling now with my little pointer or hand. Okay. I hope this is visible to you from where you are watching. This now is the table of contents of the dataset of zinc. Do not get confused by this working context being shown here. This is actually not clickable. You can see the little forbidden icon that when I go to the DWD application, this still recalls the working context of where we came from. If I were to open this zinc dataset from the beginning on its own, then it would show DWD data for relevant chemical species. But here we are we open a little window from the main dataset before we go back to the main dataset. What I wanted to show here to you is, of course, the shorter table of contents, but what you really need for zinc is practically very, very little. You need in section 1.1 to provide a reference substance here, which is zinc with CIS number, CAS number, and so forth. Again, here you need to declare that it is another type of applied for entry / relevant chemical species and put in the remarks relevant chemical species, and you don't need anything else. In the specific case of zinc, you don't need anything else. We don't need any classification for zinc. Physicochemical properties, you may see them, but as I mentioned several times already, for constituents and impurities of metallic and inorganic compositions, you don't do anything. And for toxicological data, it's also empty because I have waived the toxicological data. I'm relying on an SML value from food contact materials legislation to generate an MTC tab value. Okay, so but one important point to remember about this, it may look almost empty, but you need to create this data set. You need to create a data set for zinc, for copper, for lead, for nickel. When it comes to alloys, you do need to have these data sets, even if they are very, very empty, because you have waived the toxicological properties. If it was titanium, for example, molybdenum, bismuth, then you would have more information there because you would not be able to waive the toxicological data. There is no SML for bismuth. You would have, depending on its migration tier, provide the relevant toxicological data. So this section 7 would contain information for that relevant chemical species. And bismuth is just an example to make the point. We're not going to be focusing on bismuth too much. So I'm clicking on these little two arrows that go to the left, and I'm going back to my main data set, which is what I was showing before with the ethanol and the zinc. And I think this is basically it. Just to recap, you need to create in section 1.5 a number of documents of records depending on how many relevant chemical species you need to report. You need to identify the material type. You need to make the link to the relevant data set which has been created with the working context DWD data for relevant chemical species. You need to provide the migration tier. Let me show also while I'm talking to remind you. You need to then waive or not the physicochemical or toxicological properties, and then this is it. It should be fairly straightforward. Of course, it may be as simple as zinc. It could be as complicated as something which you need to provide lots of information for. And I think this was the end of demonstration for this point. We would welcome any questions on how this worked out. I hope it was clear. If not, please let us know. I will try to go now back to the slides. And I think this will be the last presentation from me for today. So there will be a little bit more variety coming up soon. Let me see if I can move to... No, actually, we have a break now. We do have a break. Yeah, for me as well, it will be useful. We are supposed to have a 15 minutes break, but we can take a little bit longer. We're going to be back at 11:30 our time, which should be 10:30 for most of you. Thank you for your attention. I hope it has been useful so far. I hope it has been practical. Any questions? Very happy to receive them. Thank you. Hello, welcome back. I hope you had the chance to have a coffee break. We will continue. We have 2 more presentations before our lunch break. The next one is on the dossier header, which is an important part of the dossier, and the next one will be on the substance identity, and that is going to be a very important section that I would really strongly encourage you to watch it very closely. So let me organize all my gadgets here. So yes, we are going to have some variety of presenters soon. This is my last presentation for the day. I will move to the dossier header. It's very important because it includes key information that defines the scope of your application. It also plays a vital role in instructing the validation assistant what scenario to consider when checking the contents of the datasets and the dossier that you have generated. The presentation will be very short. We will go almost straight away into the live demonstration to see how you can create the dossier header. I have already created one, but I will go through each step again to see how I made the different choices for my imaginary application. Now, in this slide, what I have tried to do is to open the dossier header for the first time when it's completely empty and make a screenshot of it. Obviously, it's quite long, so I split it into 2 parts. The first part, the upper part, is number 1 screenshot on the left, and the bottom part is screenshot 2 on the right-hand side. What you will immediately observe is that there are several fields which are marked as mandatory. This means that you must fill them in order to save the dossier header and move to the next part of Euclid that you would like to fill in. So at the beginning, you may need to give a response that you may come later on to revise because you have received some information. There is a question, for example, or a field about the migration tier of the applied for entry. Maybe when you start creating the dossier, you may not know this. You give an answer, receive your results from the laboratory, find out what is the migration tier for the applied for entry, and then go back and update, if necessary, your option. But the mandatory fields are there for good reasons, because this is information you need to be providing at all times. Now, the dossier header can be generated as the first step when you first start creating your dataset for the applied for entry, or you can do it at the very end before you go into running the validation assistant to do the validation of your dataset. You will see the dossier header there. Indeed, if you had not filled it in before the validation assistant can run, it will ask you to provide the information in the mandatory fields. I think this, oops, I went too fast. We will go now to the demonstration. Give me a moment to try to move to my, no, that's not what I want to show. I want to show this. And yes, I hope you can see on my screen. This is another imaginary dossier that I have created, which is practically empty with the exception of the dossier header. The dossier header, it is up here where I'm hovering with my little hand. It's at the very top of the table of contents. I will click this on. Okay. The scenario I'm using here is just to be clear, it's made up. I assume that I'm applying for 1 octanol as a monomer. And this 1 octanol is covered right now by a group entry in the European Positive List for organic materials. Okay, so starting from the first top block of fields, which is called dossier template, you need to give your dossier, what will eventually become your dossier, a name. And this is something that is a free text field. You can write whatever you want. It's not very long. I think there's a character limit. It's basically something you need to provide to make this memorable to you, to understand and distinguish it between the potentially several different datasets and dossiers you may have on your account. So I just wrote something simple, DWD application for 1 octanol. The dossier subject is about the submitting legal entity. What is presented here should ideally match exactly what you have added into your ECHA account, the one you need in order to access Euclid and in order to access the industry portal to make your application. But even if there is differences between this one and what is in the industry portal, it is not necessarily a problem. The key instruction here is leave this be. Do not touch it. Do not do anything with it. ECHA will not use the information from this field. All the information about your identification or about if you use a representative or whatever will come from the industry portal. So the submitted legal entity, just let it be. It will not make any difference. The dossier submission remark is also another free field which you can use as you see fit. If there is as a space perhaps that you cannot you can provide information where nowhere else can be provided. I cannot come up with a very good example, but it is there for you to use. One more thing to show before we move on is something that you will find very often in Euclid. There is this question mark icon just next to the title of the field, and I will click it now, and you will see that when you click the question mark where it exists, you will see the so-called help text, and the help text is very important. In some cases gives you really a lot of information to understand what you need to provide, in what format, to what level of detail, and so forth. So there is a little bit of help text here. I will not go through it. It's not really the most important thing. This is just a field that you can use as you see fit. We're going now to the most important parts of them, of the dossier header, the dossier specific information. The first sub area of this is the scope of the application. There is this mandatory tick box, which I will untick just to show you that it is mandatory, where you confirm actively that the contact materials in your application do not fall under the scope of Article 12 of the Drinking Water Directive. Now, Articles 11 and 12 are mutually exclusive, which means materials that are covered by Article 11 are not covered by Article 12 and vice versa. This is the interpretation of the legal text by the Commission. We do appreciate that some stakeholders may have different interpretation, but right now, the way this has been implemented is to take the Commission's interpretation into account, and which means that if you are having any aim for submitting applications for ion exchange resins, filtering membranes, sacrificial anodes, this fall under Article 12, not under Article 11. So making an application for the positive list is not relevant in that case. So I'm taking this tick box to move on. Then there is the application type field where it's a pick list of 3 options: new, review, removal. New when I want to add something new, a starting substance, composition, constituent in the European positive list when it does not exist. Review to review an existing entry in the positive list, and removal to remove an existing entry. Something which is relevant to the scenario I have built up here is that I have an application for a member of a group entry which already exists in the positive list. This one octanol, there is a group of octanols in the positive list approved right now. In this case, because you are trying to review partially perhaps a group entry, the correct choice is review. So if you have a group entry in the positive list and you want to apply for a specific individual member of that group entry, the correct answer here, the correct choice from the pick list is review of a starting substance, composition, or constituent. Moving on further down, material type is the pick list that you will encounter many times in Euclid, because as I mentioned before, this really runs dynamic content rules. I choose organic, I see some fields. I choose metallic, I see other fields. That's why many times you need to answer this question. And of course, it's very important to make it consistent. So if it is organic, please, in every single place, you need to select organic materials from the pick list, which I will show you as well. Organic materials, this is my choice. Now, in my example here, in my scenario, the question is the applied for entry a member of a group entry in the UPL? I have chosen yes, because it is in my imaginary example. I could choose no. It's a pick list between, you choose between yes or no. When I choose, let me choose no. You will see that this field would have to be empty. Okay, if I had chosen no, it does not exist, the field. But if I choose yes, like I did do in my example, yes, a new field appears with the EUPL number of the listed group entry. You need to be aware of this. If you are applying to review or perhaps remove a member of an existing group entry, the EUPL number of the group entry is given in the dossier header, 1581, if I remember correctly. But if you are applying for an individual substance, which is either new substance or composition, or it is already an individual substance in the European positive list, then the EUPL number for that goes into the reference substance, specifically the synonyms of this reference substance. We are going to show this in a moment, but here the key takeaway is that you are applying for something that belongs to an existing listed group entry. EUPL number is given in the dossier header, which I have given is a 4-digit number. You can see it in the table of the tables of the annexes of decision 367 of 2024. The next field is a very important one. It has a very detailed help text. I will close it not to distract you with you trying to frantically read everything through it. Here, you need to, in your own words, to explain the scope of what you're applying for. In many cases, this will be very simple because it is an individual entry or it's a new entry. You don't have to say much. It's just, I'm applying for this individual substance. But when groups come into play, then you do need to explain whether what you're applying for belongs to that group and justify this, or there will be some cases where unfortunately the legal text is not entirely clear or correct in saying that something is individual or group, and you do need to explain your position. One example that we have used in presentations before is that some entries in the European positive list, for example, in table 2 of Annex 1 of Decision 367 may appear as group entries, but in reality they are UVCBs. And you may have good technical and scientific justification to explain that I'm applying for entry 1622, which is, in my view, is not a group entry, is a single entry because it's a UVCB, and you can provide some explanation. So take this, take the time to address this scope of the applied for entry field very carefully. When you need it, you really need to provide sufficient justification. But in many cases, we appreciate that you may not need to write much because the case is very clear cut. Okay. The next part is the type of applicant. There is a yes/no question whether the applicant is an authority or not. I assume that I'm a company, so I have selected no from the pick list option. And then we come to the perhaps more interesting part of the dossier header, where I provided data-related aspects of the application. The first question is whether the application identifies the applied for entry as the relevant chemical species. And this is a pick list that has a number of options and perhaps incorrectly identifies the possibility of you ticking more than one. My advice to you is tick only one. The selection should be between yes and no. It doesn't matter which yes you select, especially particularly you are dealing with organic or cementitious materials. Just choose a yes if your applied for entry, your starting substance is a relevant chemical species, or choose a no, because for whatever reason, maybe your starting substance is not a relevant chemical species, but you have an impurity, which is the relevant chemical species. I'm not sure if this is a very realistic scenario, but it is theoretically a possibility. So there are a number of yeses, and there are a couple of no's. There are 2 no's and 5 yeses. Choose one yes if the answer is yes. Choose no in the case of organic or cementitious materials if this one is the answer no. Obviously, my example on the screen is really incorrect. Do not get confused. You cannot give both a yes and no answer. Do not ever do that. This is just for demonstration, okay? So I just wanted to click on the option. So if it's a yes, choose a yes. If it's a no, choose a no. Another important point before I move on is that out of this pick list of 5, the only correct answer for metallic and inorganic composition, it is the bottom one. It is no. As I explained in a previous presentation, the applied for entry, if it is a metallic or enamel or ceramic or other inorganic composition, it is never a relevant chemical species itself. It gives rise, it releases potentially relevant or not potentially relevant chemical species, but it itself, the alloy, it is not a relevant chemical species. We do not care about the toxicological properties of the alloy. We may care about copper, zinc, titanium, molybdenum, cerium, bismuth, and so forth. So for metallic and inorganics, only no here to the question, does this application identify the applied for entry as a relevant chemical species? I have messed it up a bit, so I will go back to a yes. I will choose just a yes for my scenario. The next question is about the migration tier of the applied for entry. You will see now the similarities between the dossier header and section 1.5 for the relevant chemical species. In some ways, section 1.5 of the main data set, which is here, let me just open it for you to see it again down here, it acts a little bit as a dossier header for the relevant chemical species. So again, to return to the dossier header, I select from a pick list option what is my migration tier. I chose low, could be medium, could be high. Low means that the concentration at the tap is below 2.5 microns per liter. And then there are the two questions about, am I waiving the physicochemical data or toxicological data? And what I present before still applies. If I get selected yes, there will be a justification field to show why I'm waiving physicochemical data. There is the possibility of choosing one of these, and please choose just one of option. I don't think usually applies more than one, but even if it does, one is good enough. You explain that I have a parametric value, for example, and that's why you waive. And I'll put it back as a no. I do the same for toxicological data. It's a yes and no answer. And if I give a yes, I need to justify. And now I should have been removing this just for to avoid the confusion. This is the end of creating the dossier header. Okay, when I'm making my initial application to ECHA, this is how I fill in the dossier header. I give it a little bit of names to understand what it is about. I confirm that I'm not relevant to Article 12. I indicate whether it's a new review removal application, material type, whether it's a group entry in the European positive list, the scope of what I'm applying for, the type of applicant, and then a little bit of the content. So the validation assistant, to know that, the applicant says that the migration tier is low. So when it comes to toxicological information, I need to focus on whether genotoxicity/mutagenicity information has been provided. So I can save it, and this is done. Now, later on, there is a possibility of receiving communication from ECHA during the accordance check. And we go through the accordance check and we find that you have omitted something, you have done something which is not clear to us, you have not met the information requirements. You are going to receive communication that explains the reasons why you have failed the accordance check, and it will give you a period of time which is defined in the Regulation 369 of 2024 to put things right, to improve your dossier. And there are two steps to that process. There is the so-called scope check, where if you fail it, you are given 1 month to resubmit. And then there is the information requirements check, the main part of the accordance check, where we check the contents actually to tell you that you have not met the information requirements. And there, if you fail it, you have 6 months to come back and resubmit your application. And this is what I want to show you now. Imagine that you have received communication. ECHA has told you there are some mistakes, there are some problems, you need to improve them. You need to go back to your data set, not the dossier, because you cannot edit it. You go back to your data set, and apart from changing, obviously, other contents throughout the data set, because you need to make changes in section 4, 5, 6, or whatever, then you need to come into the dossier header, and then you need to tick this box, the submission is an update. The submission is an update. So I click this box, and a mandatory new tick box appears, which is further to a request/decision from ECHA. Why this is there? Because we want you to actively confirm that the submission you are making is not a spontaneous submission, because we do not accept spontaneous updates to applications after you make your submission. To put it simply, you submit an application in January. If in February you decide that I need to change something in my application, you cannot do it. The only way you can make changes to your application is to receive a request from ECHA to tell you you have failed because of reason XYZ, please improve your application, and then you make an update. An extra reason to give the message to you, which I think it will come tomorrow as well, please aim your initial application to be complete and correct. Aim for the best job you can do from the beginning. Do not expect that I will put something in, I'll try to improve it later on. Also, the time you are given to make improvements, those 6 months I mentioned, if you have a problem with the information requirements, in many cases will not be sufficient if you want to create new data, to obtain new data. So do not expect that you are coming in with something which is half ready and hopefully you can improve it in the process. Possibilities for improvement exist, but they're very limited, and it is on ECHA's request. So I need to take this mandatory tick box, which I tick. Then I need to add this to plus new item. I click is also a mandatory field, and that creates 2 new fields. The number here is the communication number of the letter effectively what you're going to receive from ECHA. And it will be something, I don't know, communication 1, 2, 3, 4, 5. I'm making something up. It is not important right now, but you need to put something that will come to you from ECHA. You need to look into the communication from us that will be given clearly as a reference number. The remarks on the update, as it's explained in the help text, it's basically you need to put some explanation of what you are changing to your dossier. It is possible that we say you have a problem in section 7. I don't know if it's a good example, but you may end up also, because of this change in section X, you make also changes section Y. We need to be very clear where you have made changes. So please provide a good and accurate and complete summary of what you have changed. It's a free text box. You can write, obviously, I think there is a 2,000 character limit I see here at the bottom. Let me highlight this for you. This is the, oops, sorry, it moved up for some reason. There's a character limit of 2,000 characters. Please do obviously do not write too much. Write enough for us to understand what you have changed. So I will add something here just for the sake of being able to save, and I will save this. So I'm ready now as far as the dossier header is concerned. With my updated dossier, I can updated dataset to be correct. Then I can create my dossier from the purple button up here, and I can move on and make the submission through the industry portal with my updated dossier. I hope this was clear. And I think we can move now to the next presentation. We're going to change presenters. We're going to switch the camera and the microphone for a little bit while we're moving around. So thank you for your attention so far. We're moving to substance identity, very important point. Please stay engaged. And actually, I wanted to make one point before I move on. We have seen, first, we do receive your comments. There are some questions that are coming through. We don't need to repeat them. Maybe participants fear that we don't get the questions and they tend to resubmit them. Submit them once and they will be fine. Something to clarify about the previous presentation about the Euclid application manual. We use a terminology which perhaps is confusing, but to be absolutely clear what we always mean. The ECHA guidance documents, and I will be presenting them at the end of tomorrow. They are scientific documents, and there are 4 volumes from ECHA and 1 volume from JRC. This is a separate thing. They are very lengthy. You need to look into them to understand the scope of applications, to understand what you put into the notification of intention, and also in the applications. 4 guidance documents, we call them. Then we have the practical guide, which is a guide, very practical, with very practical advice and lots of links to different resources, which is sitting behind the infographic we have published on our website. This will become clearer tomorrow. And the last thing I need to clarify term is the manual. This is what I was presenting earlier, and there were some screenshots of tables from the manual. This is the Euclid application manual. Like we have the Euclid notification of intention manual. These are documents which go into Euclid that tells you when you see filled this, and there are 3 options, choose one. If you choose that one, something else appears or disappears or whatever. This is the manual that really helps you understand how to use Euclid. It is in that manual that we have this big table with the mapping that says information requirement X, you address it in Euclid section Y, and if you want guidance, you go to the guidance document, volume 1 or 2 or 3 or whatever it might be. I hope this is a bit clear because I saw a question came in and I wonder if other people have this query. So we have guidance, practical guide, Euclid manuals. We don't have guidelines. Maybe we are getting confused because somebody was asking about guidelines. I'll switch now the audio and the camera on. We're going to switch presenters and we'll start in a moment. Thank you.
Good morning, everyone. My name is Nuria Puchpinos Angel. I'm a scientific officer with chemistry as background, and I'm working in the Drinking Water Directive team. Welcome to the demo part 2, description of the identity of the applied for entry. So during this demo, first I will remind you about the information requirements related to the substance identity and the Drinking Water Directive. I will outline the relevance of the 2 working contexts. And afterwards, I will make a demonstration on how to fill in the relevant sections in Euclid to identify the applied for entry for a DWD application. Finally, we will complete this demo by going more in depth on some special cases like the nanoforms, polymers, and the prepolymers. We will start with a reminder on the information requirements that apply to the substance identity information of the applied for entry, as defined in the Implementing Decision 2024-365 Annex 1. Point 1.1 to 1.5 list all the applicable requirements, and in the following slides, we will go through point by point. I would like to highlight that the substance identity information submitted in the application must be sufficient to 1, identify the applied for entry based on the requirements of the specific material type, and 2, to characterize it accordingly. Next, we will review the information requirements, and at the same time, I will show the EUCLID section where each of the information requirements must be provided in EUCLID. This mapping of information requirements and EUCLID sections is already available in the EUCLID manual, as we were just, as Panos was just explaining. To make this exercise easier to follow visually, I highlighted in yellow all the information requirements that must be included in EUCLID section 1.1. In dark blue, all the information requirements that must be included under EUCLID section 1.1, in 1.2, and in light blue, all the information requirements that must be included in EUCLID section 1.4. Point 1.1 above in this slide describes information requirements to name for name or any other identifiers. Highlighted in yellow, points 1.1.1 to 1.1.6 refer to the name, EC number, CAS number, and UPL number if available. These need to be included in the reference substance in EUCLID section 1.1. Point 1.1.7 is not applicable to substance identity section in EUCLID. It should be included in the uses section, EUCLID section 4. And then highlighted in blue, right under, points 1.1.8 to 1.1.12 are only applicable to metallic compositions. Points 1.1.8 to 1.1.10 in the first box in dark blue only apply to new metallic composition categories and to existing categories that must be modified. The identity of the new metallic composition category, together with its constituents and impurities, must be included in EUCLID section 1.2. In this case, in the type of composition field, the boundary composition must be selected from the pick list, as I highlighted in this in the slide. And points 1.1.11 and 1.1.12 are only applicable to new metallic composition categories to provide the reference material. The identity of the metal constituents and impurities of the reference material must be included in EUCLID section 1.2, and in the type of composition field, other must be selected from the pick list. If the alloy you're applying for has already a metallic composition category and it does not require any further modifications, then points highlighted in blue in this slide are then not applicable. Point 1.2. In this point, it lists the information requirements related to the molecular structural formula or crystal structure. Points 1.2.1 and 1.2.3, highlighted in yellow, in this slide refer to structural and molecular information of the substance. This applies only to organic and cementitious materials and must be provided in the reference substance EUCLID section 1.1. For metallic and inorganic compositions, instead, the crystal structure information shall be reported under EUCLID section 4, which refers to the uses section. Point 1.2.2, highlighted in light blue, refer to the optical activity and typical ratio of stereoisomers. This must be provided, if applicable, in the composition block in EUCLID section 1.2, where you can report the typical ratio of the stereoisomers, and in the optical activity field in EUCLID section 1.4, where you must select from the pick list whether the applied for entry has optical activity or not. Point 1.3 outlines the information requirements related to chemical characterization. Points 1.3.1 to 1.3.3, highlighted in dark blue, refer to content of each of its chemical constituents and impurities of the applied for entry. These information requirements must be provided in the degree of purity, constituents, and impurities blocks of Euclid section 1.2. In this case, in type of composition field, legal entity composition must be selected from the pick list. Points 1.3.4 and 1.3.5 in light blue below refer to all necessary qualitative and quantitative analytical data to characterize the substance, together with the respective analytical methods and results. This information must be provided as attachment in Euclid section 1.4. Please note that for metallic materials, no new data must be generated for the metallic composition. The same information as provided for the analysis of the test piece can be attached in Euclid section 1.4. Point 1.4 outlines the information requirements related to the characterization of a nanoform. This information requirement applies only to organic and cementitious materials. And all the information that must be provided to characterize a nanoform is described from points 1.4.1 to 1.4.5 must be filled in the block characterization of nanoforms in Euclid section 1.2. This block will only expand if in the field state form solid nanoform is selected. I will show you later in the demo at the end of this presentation. And 1.4.6 in light blue refers to all necessary analytical data to characterize the nanoform. This information must be provided as an attachment in Euclid section in block analytical determination for nanoforms. If you need any further advice to characterize your nanoform, you can have a look at section 3 of the appendix for nanoforms. This is very helpful to fill in the Euclid. And the link is provided in this slide. And the last block of information requirements, point 1.5, refers to additional information required for polymers and prepolymers. First of all, I wanted to highlight the guidance on Drinking Water Directive, Volume 1, Section 2.1.2, where you have the naming convention for polymers. I would strongly recommend you to have a look at it if you're planning to apply for a polymer. Most of the information must be provided in Euclid section 1.2, except for 1.5.4 in yellow, which refers to the structure of the polymer and prepolymer, which must be attached in the reference substance in Euclid section 1, and point 1.5.5, which refers to the test report results with the molecular mass distribution, which must be attached in Euclid section 1.4. Points 1.5.10 and 1.5.11 must be provided under physical chemical information in Euclid section 3.14 and 3.15. From all these information requirements, there are some differences depending on the working context. So for DVD application context, you must fill in Euclid sections 1.1, 1.2, and 1.4 as per the information requirements. And for drinking water relevant chemicals species, only section 1.1 in Euclid must be filled in. Now let me walk you through how to complete Euclid section 1 to prepare a DVD application. Firstly, I will show you an example of how to prepare a dataset for an organic material and then for a metallic composition. And I will highlight the main differences. I will start with a review application for an organic material. In this slide, I have prepared all information I needed to prepare my Euclid dataset for my substance. For Euclid section 1.1, the applied for entry name and UPAC name, ideally they should be identical, so we prevent any any issues with ambiguity on the substance identity. So I would strongly recommend you to use identical names in both fields. Then for this particular substance, there's a UPL number already. So I take note of that. I find the EC number and CAS number are also available. So I gather it. Molecular and structural information. For organic substances, this is information requirement. So it's important that this also provided in the reference substance of Euclid section 1.1. Then for Euclid section 1.2, I need to have a clear degree of purity and the concentration ranges of my constituents. In this case, it's a monoconstituent substance. There's only one constituent, which is 95 to 100% present. And then there's an impurity xylenol, which is up to 5%. So it's important we have this clear. And then for Euclid section 1.4, I need to have all the methods and results of the analysis that support all the information above. So in terms of qualitative data and quantitative data, you should have it all together and ready so it can be attached. And for this particular substance, there's no optical activity. So this is also clear. We have all the information we need. So we will move to the Euclid dossier. And just a second. Okay, so we move to section 1.1. We have I have prepared already the dossier. I will show you what we have seen on the slide, how it should be looking in the Euclid dossier. So we have the applied for entry name in the first field, then the reference substance. It's already available. I will click on it so we can see all the information. In the reference substance type, for drinking water, only the first option is applicable. So we would select chemical. And then for reference substance name and UPAC name, as described before, we would expect identical name. So we prevent any ambiguities on the identity of the substance. Then in the inventory number field, if you click on it, you can type your EC number if available. In this case, here it's 7, 3.1. So it shows, if I don't put it completely, it shows all the repository of EC numbers that are available. But if I put complete number, then I should have only one. I click on it, and then it appears on the inventory number. Additionally, if a CAS number is available, you can add it in the CAS number field. This is a free text field, so there's no repository. Only the inventory number has a list of EC numbers available. But CAS number you can type if available. Same for the CAS name. In the synonyms, as Panos already mentioned before, for single entries, we need, if UPL number is available, we need to include it in the synonyms table. So we click on the new item above the table. You can see that there's a new row created on the table. I click on identifier. I look for DWD UPL number. And then I need to click on the relevant, the next box, identity. And here I would indicate the UPL number. And that would be it. If there's no UPL number available, we would leave this field empty. Then the molecular and structural information, I would fill it in with the information relevant to the applied for entry. And that would be it. I would click on save. And this message will show you that the document has been saved successfully, so we can move on. We have one last field in section 1.1, the type of applied for entry / relevant chemical species. In this case, we have it's monoconstituent substance. There's only one constituent. But if you have more than one constituent, you should select multi-constituent instead. Or if you have a big variability or there's some unknown in the applied for entry, you could select UVCB instead from the pick list. So with that, we would click on Save, and then we move on to section 1.2. Here, we select for organic and cementitious materials, we would select legal entity composition of the substance. There's also boundary composition and other, but this is more relevant for the metallic composition. So we'll show you in the next data set. Here we select what is the state form that is applicable to the applied for entry. And the description field, this is applicable for UVCB substances, where there's more complexity and manufacturing of the description of the manufacturing process is expected. You need to provide that for UVCB and for polymers. I will show you later when we are in the polymer section how to fill in this information. Then the degree of purity, we had this ready, so it can be included in these ranges. And in the constituents, I have already filled it in. You can fill in as many constituents as you want by adding on new item and defining the typical and concentration ranges as relevant. For our case, we have the applied for entry. For monoconstituents, this should be the same. For multi-constituents here, you would have multiple entries. And you actually, I could show about the reference substance. I think there was some question about do we need to create always a reference substance even if it's empty? The reference substance is required for the applied for entry, for constituents, impurities, additives, and for the relevant chemical species. So Euclid works this way. Whenever we have to provide this information, you need to create your own repository of reference substances. If it's already available, this is only for your Euclid account. So I can see only the reference substances that I have created previously, and then I can select from here what has been already created, or I can create a new one if I don't have anything yet, or I need something that is not yet available. By clicking on create on the create button in orange, you get a completely new reference substance, and you could write whatever here, and you could add the inventory number, everything as I was showing before, and click on save, and then it would be available here, and you can continue with your work. In this case, I'm not going to save it because this is a monoconstituent substance, and I wanted to have only one constituent in this table. Below, in the impurities, I would do the same, add new items, add the reference substance. If it's not available, I would create it from scratch. If otherwise, if it's already available, then you can add it, and then add the typical concentration and concentration range. There's no additives for my substance, so my substance is not a polymer either, so I would have the section 1.2 ready to move forward. And last, okay. It's very important to save every time, otherwise you will not be, you will always get the reminder from Euclid. And last, for this data set, we have the Euclid section 1.4, analytical information. Usually, even if you have multiple reports, it's usually provided within one document. Only you don't need to create multiple documents for each of the reports. You have only one, and you can add multiple items for this table in this analytical determination table. And if your report includes identification and quantification, you can select that. Otherwise, if you have multiple reports, you can specify which is the purpose of the analysis you're attaching. Then the analysis type. In my case, the report includes qualitative and quantitative data. So in this case, there's NMR, IR to identify the substance, and chromatographic method to quantify the substance. It includes also the methods and results, so I can select this from the pick list and then attach the report with all the information. This information is supporting the information in section 1.1 and 1.2. This is very important because if not, then we cannot reach conclusion when assessing the information, and we might need to contact require further information, basically. And the last field, optical activity. In this case, it is not optically active, so I just select no from the pick list, and I would save, and the data set would be ready to go. I would create my dossier, clicking on the purple button, and I would be able to submit it. That's for the organic material. And then we can look next to the metallic composition data set I have prepared here. I believe that it was reasonable to have one example of each because they have some differences. So it might be relevant for those of you that are planning to apply for a metallic composition. In this case, the main difference in Euclid section 1.1 is that in the applied for entry name field and in the reference substance name and the UPAC name fields, you must provide the standardized material designation. It's not the typical UPAC name, but it's what is expected for metallic composition materials. And easily the EC number and CAS numbers are not available, and molecular and structural information are not an information requirement, so they are left empty. If there's a UPL number, you can again go to the synonyms table and include it in the table as I showed previously. And in the type of applied for entry, you would need to, you have all the metallic and the inorganic composition is also available here, so you could select from this pick list. And we would be ready from Euclid section 1.1. For section 1.2, I'll go back to the slides because I believe there's something I want to share with you that I want to make it clear. Just a second. So I prepared this table to make it as visual as possible because it's a bit challenging maybe to understand. So for Euclid section 1.2, for metallic compositions, depending on your scenario, you might need to create one document or more than one document for applied for alloys for existing categories, only the legal entity composition is needed. And there you need to report the composition and impurities for the applied for alloy. If instead you have a new metallic composition category, the composition category does not exist yet, then you need to create 3 documents in Euclid section 1.2. One for the applied for entry with type of composition, legal entity composition. A second one for the metallic composition category as in boundary composition in the type of composition field. And a third one for the reference material with type of composition other. The third scenario would be when you need to modify an existing metallic composition category. In that case, only 2 composition documents are needed. One for the applied for alloy with legal entity composition step for composition and metallic composition, and the second one for the metallic composition category as boundary composition. If I think that's all what I wanted to say, but I think this is very important, and this table summarizes all these possible scenarios you might encounter. Furthermore, I would like to provide two technical important recommendations. First, that in certain cases, for example, zinc-containing copper alloys, concentration of the zinc constituent is typically declared as reminder in the approved composition category. If so, then you need to add the word reminder in the remarks field. Since it's not technically acceptable in the concentration fields to type words, only numerical values are allowed. And second, the presence of additional zeros in the fractional part, like 50.0%, might have significant implications on what concentrations are allowed. And again, this is not technically supported by Euclid to add this additional zero in the fractional part in the concentration fields. So please add the complete number in the remarks field instead. And regarding section 1.4 for metallic compositions, just to remind you, I already mentioned that before, but just to complete this in this data set for the metallic composition, no new data must be generated. Same information as provided for the analysis of the test piece might be attached in section 1.4. I will go back to Euclid to show you how about these different scenarios, how to fill in Euclid. So if I go now to section 1.2, I have already created here the first one. In this particular one, in this particular case, there's already metallic composition category. So with one composition document is already sufficient. And here I selected in the type of composition field, legal entity composition of the substance. And I fill in the constituents. In the constituents table, I added reminder in the remarks field, just a free text field. And for copper, I have added, actually, it was for this metallic composition category, it's been approved. The copper is present from 89.0% to 91.0%. And I had to add this in the remarks field because Euclid doesn't allow me to save if I type 89.0. So please use the remarks field for that purpose. And here we have the impurities concentration. The upper concentration range has been provided for all the impurities. In the case where I would need to create additional composition documents because there's no metallic composition category, or if I need to modify the metallic composition category, I need to click on the plus here, add a new document. And here I will name it now metallic composition category. And in this case, then I would define in the type of composition field the boundary composition of the substance. Then I would come here, add the constituents in the constituents table. I'm not going to go through all of it, but I just want that the idea is clear how to fill in Euclid section 1.2 depending on your scenarios. So I just save this one. You can see that now this has changed based on what I have added in here. And if I have a new metallic composition, I would still need to add a third composition document. So clicking again on the plus button here, and then adding reference material. And then for this case, then other would be would need to be selected, and constituents and impurities then would be included here. And with that, I would have ready section 1.2 for new metallic composition. This is the second scenario. If we are talking about the third scenario where we need to modify the existing composition category, I would only need 2. So first and second would be sufficient. Third one would not be needed. And yeah, this would be sufficient for you for the third scenario as described in the table. And for 1.4, I already mentioned that this information is already is the same as for the test piece. So no need to generate additional information for this purpose. That's it for the metallic composition data set. And I will jump to the special cases. Maybe I had one slide, but actually I can continue in Euclid and show you the special cases, nanoforms and polymers. I will start with the nanoforms. So in this section, I wanted to highlight the naming for nanoforms. There's no specific guidance on how to name nanoforms, but we give you the advice to be as specific as possible. Because for drinking water, you need to apply for each of the nanoforms separately. So the more specific you are, the better we can identify your substance. And we would suggest you to refer to the, like in this case, zinc oxide, then a comma, the nanoform. In this case, we have defined the spherical and the size 20 to 35 nanometers. And then if there's any surface treatment, then you could add as well that on the name. So the name, again, we use the same as for the applied for entry, reference substance name and the UPAC name. Then in the EC number, you would need to select the EC number not for the specific nanoform, unless it's available, but you should select in this case, for the zinc oxide, for the bulk entry. And then the CAS number, if available. In this case, this is a new application, so there's no UPL number available, so I will leave the synonyms table empty. And then for the molecular and structural formula, then I can include it here, but the crystal structure is provided later on in the section 4, as I mentioned before. Then we move to, for the type of applied for entries, monoconstituent substance, nothing special here. And then in section 1.2, I wanted to highlight a very key field that will enable the relevant block to be displayed, to be expanded. If you select solid bulk fibers, other state and forms, the nanoform characterization of nanoform block will not be enabled. But if you select solid nanoform, then it will expand below. So for the constituents, there's nothing special, as it's the same as for the organic substance. And then below, this characterization of nanoforms block is enabled thanks to this state and form field. And here you need to provide all the information that is relevant to characterize nanoforms. I wanted to pay particular attention to this shape and category field. Depending on what you select, it will change the editable fields below. So if I select spheroidal, then only these 2 fields are available for editing, whereas the other ones are grayed out. If I change to platelet, then additional fields become available. So just for you to pay attention at that when filling in the dossier. And a second aspect I wanted to highlight was related to the to the description. That was for the surface functionalization. In the description field, if the applied for entry is a nanoform and you have surface treatment, then you need to click on the description to describe the process of functionalization and the functionalities being introduced. We recommend you to use this button here, insert existing template. When clicking on it, additional parameters will be added on this in here. So it will guide you on what is the expected information you need to provide in this field. And that would be it for the nanoform for Euclid section 1.2. Probably I will need to save. And then for Euclid section 1.4, here, in addition to the analytical determination table, you will need to provide also an attachment and analytical determination for nanoforms. So in the first table above, you need to provide any information to support the identity and quantification of the substance. For example, with IR, XRD, this type of spectral data. And for the analytical determination for nanoforms, you are expected to provide information to support all what has been provided in the characterization of nanoforms in Euclid section 1.2, like particle size distribution, shape, crystallinity, surface area, and this type of analysis would be expected as an example. So yeah, just to make this clear, this is the only type of substance where both tables need to be filled in. So just wanted to highlight this in this data set. I will save just in case. And I will go to the last data set I have prepared for this demonstration today for the polymers. So for polymers, again, trying to use the same name in the different name-related fields. If I click on the reference substance, I wanted to show you that the structural formula is added here also for polymers. We are expecting the structural formula to be provided in the reference substance. There's no dedicated field elsewhere, so please provide the polymer or prepolymer structural formula in here. And the type of applied for entry, please select polymer from the pick list. Is the most applicable. Then for probably no, not needed. For Euclid section 1.2, as I mentioned before, well, if you click on the description field is very important field for, as I said, UVCB and also for polymers and prepolymers. Here you need to provide the description of the manufacturing process, and you have also this option that will guide you through what is expected, what you need to provide here to understand better the polymer. You can click on Insert Existing Templates, option 2. Even if it says a composition of a UVCB substance, the same applies for the polymer. So if you click on option 2, you will have additional parameters that will guide you through what is what information we are expecting for the description of the manufacturing process. And then another relevant, just showing here for the constituents. Actually, I wanted to highlight as well that we need to, you need to include in the remarks field whenever you're reporting a residual monomer, you need to indicate it in the remarks field so that it's clearly stated. And you need to provide the concentration ranges for all of the constituents, including the residual monomer as well. This is quite a complex composition in comparison to what we saw in the organic monoconstituent substance, but this is also reality for more complex substances. For UVCV and polymers, actually, no impurities are expected. All the constituents need to be reported under the constituent section. So that's why you see everything in the first table and nothing in the impurities. And then last but not least, in Euclid section 1.2, for polymers, we have the additional information required for applied for entries, which are polymers or prepolymers block. You need to provide this. These are the information requirements for the polymers and prepolymers. And then here, in Euclid section 1.4, in addition to the qualitative and quantitative data, you need to provide as well for polymers the test report of the molecular mass distribution. This can be done in the same analytical determination table as for the other reports. There's no specific dedicated table for this, so you can include here as well in the same table. And I would click on save. The dataset would be ready, and you would be able to continue with the rest of the Euclid sections. Before finalizing my presentation, I wanted to provide also some support material to help you with the substance identity, to how to fill in a DVD application. So just in case you find it useful, I provided here some links. Thank you for your attention, and I'm here if you have any questions.
Good afternoon. We are back. My name is Nico Helsten, and I work in ECHA's drinking water team as a regulatory officer. I'm a material scientist, and I will explain to you now about the intended uses and how to fill in the intended uses records in Euclid application. So basically, the requirements between the intended use are different for different material types. And because of this, I will go through two demonstrations first after showing a couple of slides. So I will explain in practice how to fill in the organic materials intended uses and the metallic materials in Euclid because of the main differences that are here. And let's see if I can turn on the slides. So, yes. So, intended use is actually, as I said, I will go through in a few slides some key elements about the intended uses, and then I will focus largely on demonstrating how to fill in these records in Euclid and what kind of information we are expecting to see and where. So first, describing a little bit about why intended uses. So why is intended uses required in a drinking water directive application? Well, for many reasons. First, it does describe where a substance or a composition that you're applying for is actually used, and it helps to do the risk assessment for it. It explains what kind of material you're using, what kind of product, and most importantly, how much of it would come into contact with drinking water. And this then helps to assess the risk. And also relating to this description of what kind of product and how much contact with water is, it helps in designing the migration tests you need, because the migration test should always reflect the worst case of the intended use that you are applying for. So basically, as it says here, it helps to design the migration test. And also a very important thing about the intended uses is that it helps to determine the so-called conversion factor, or the A factor for metallic materials. And this is a number that is used together with the results from the migration test to determine the CTAP. And this is a very important point of the intended uses. Then just briefly, where exactly to find Euclid. Euclid is in section 4 of the drinking water application table of contents, as shown here on the screenshot on the right. And all the fields in this particular study record, which was designed specifically for the drinking water application, they reflect the requirements described in Annex 2 of the 2024/365 Commission Implementing Decision. And as with some other Euclid study records, also with the intended uses, one important point is the material type selection, which triggers the so-called dynamic content rules. So if you do not select the dynamic content rules, if you do not select the material type, then there are many fields which are visible, but when you choose your correct material type, then many fields are hidden and only the ones which are relevant to your material will be shown. So it would be easier to fill it in. Then we've been asked sometimes in the past how many intended uses records are actually needed for an application. As a minimum, there must always be one intended use record which has to be filled in. And then whether you need one more than that one depends on how many uses you would have, with some exceptions. For organic and cementitious materials, in principle, you should have one per use. For example, if you use into different kinds of plastics and one rubber, you would need to have 3 intended uses records. And for cementitious, it would be similar case. For metallics and enamels and inorganic materials, we are mainly expecting one intended use record because these are different from the organics and cementitious. They are applied as the materials already. So the one use would determine the worst case already there. And also when we are evaluating these, only the one of the uses would be considered. And that's the one that you would be declaring as the worst case. Then I will just briefly introduce the structure of the intended use study record. So this is a section that is only for the purpose of the Drinking Water Directive application. So I don't think this exists in any other legislations we have. It's divided into these sections, the Euclid document, which you have to fill in. First, there's a little bit about the characteristics of the contact material. Then you have to describe the identity and use of the final material and product. You also have to give information on processing and internal structure as these affect the migration potentials. Also characteristics of the water, mainly the temperature of the water, because this also has important significance. Then 2 quite complicated sections, only for organic and cementitious, are the identification of NIAS other than impurities and identification of NIAS from the use of monomers or other reactants. And these basically mean any reaction or degradation products that may follow when you use your substance and to generate the actual organic material. For example, you take your fillers or other additives and add them to the mix and then process with the polymer to produce the actual plastic. If it's in elevated temperatures and higher pressures, there may be some reactions which occur. And also when you apply for when you are using a plastic, you are actually applying for a monomer, which you then convert into a polymer. And then there could be some short chains or oligomers, which could then migrate, and these have to be identified, whether there's a chance that these would be included in the final material. Then there are just placeholders for giving us any additional information and declaring whether or not a use is a worst or non-worst foreseeable use. And this is actually the slides. And now I will try to see if I can give you the live demonstration. Basically, here I have now a dummy substance or a data set that I've created for an organic material. Here is my table of contents, and I will go into the intended uses. So this particular example is, well, I've named it vinyl chloride in PVC. So just to say that this is a semi-realistic data. So it's is not really like, we don't have any real examples, so we are just using as close to something real that we could be showing as possible. But of course, when you're applying, you have to know what you're applying for and how it is used, and you have to describe this to us. So first, when we start from the top here, there is the characteristics of the contact material. So here there's a material type, organic materials, and this is something that it will be made mandatory to fill in. And this is just simply selecting from a pick list. And this, of course, is based on which European positive list you are applying for. So you have only 4 options. So that should be straightforward and simple enough, I hope. Then next, you have to also give us the organic material category. This is something that will appear on the European positive list. And here we have 6 different options. And these actually depend on now which material type you're selecting. So for organic materials, there are 6 material categories named here, and you have to choose one. In this case, because I'm applying for a vinyl chloride to be used in PVC plastic, I'm choosing plastics and polymers. Then also, again, you have to go a bit deeper than that and describe also the subcategory, because there are lots of different plastics and polymers around. And in this case, again, it's a pick list, just slightly longer, covering many materials. So you have to find your material here. And if you don't find, there's also this other option. So you can choose other and then describe your material. In this case, I have chosen hard polyvinyl chloride or rigid polyvinyl chloride. So something that should not contain any plasticizers as a default. Then there's a section called confirmation of the scope of the application. And as Panos explained this morning, these fields are actually something which do not really relate to the intended use of your substance or composition. So I will not describe them here now. I will instead jump to the next section, which is relevant to the intended use. And this would be the identity and use of final material and product. This here starts with a question applied for entry used in a surface layer. So this is just a yes, no, whether or not your substance will be somewhere used in a coating or any other surface layer like enamels. By default, they would be coatings, glassy coatings. So here you either answer yes or no. If you answer yes, there will be some additional questions that you have to then fill in, but here we are applying for a general bulk product pipe material, so we have selected no. Next, you have to select from a pick list the type of product or component you think that your substance will be used in. So here, for example, again, we have a pick list with different options, ancillaries, boilers, filters, fittings, etc. And also there's an option at the very bottom, the other. If you do not find any products that you think your substance will be used in on this list, you can always choose other and describe. And this is the kind of list where you can choose more than one. So it's possible to describe several uses. Next, there's a very simple selection using domestic or non-domestic installations, and you choose one or the other or both. Again, you can choose 2 options here. Then there is a pretext field where you can give a detailed description of the final material or product in use. So this is where you can zoom in a little bit if needed, where your actual product will be used, so where the substance will be coming into contact with drinking water. Again, there's a placeholder for attachments where you can attach files to give any additional information. Then next, there is something that is really, really important. This one here. After describing your use, you must select always a relevant product group for the organic material. And this is actually something that we have a pick list for with all these codes, A1, A2, A3. These are product groups which are actually described on the ECHA Guidance Volume 1 in one of the annexes. And they tell you what kind of products are included into which product group. And these product groups are representing of different risks from different kinds of products. For example, pipes, which have a high surface to volume ratio and high contact surface, they have a higher risk than some small bits of, let's say, pumps, for example. So this product group is really important, and I think it will be even mandatory in the application. So you cannot submit your application without stating this. Then you can also indicate surface to volume ratio. This is actually coming from the product group if you choose one. And also, very importantly, there is a worst case conversion factor relevant for the applied use that you must choose. And this is just the number field. So here you can give any number you think, with 20 being the maximum, so 1 to 20. There's also the so-called help text, which is very useful in many pages in Euclid. So the question mark here, which explains you that for organic, cementitious enamels and other materials, the worst case conversion factor is 20. If you do not know it, the default value, you can always enter 20. But this is the number that will be used to calculate your CTAP along with the migration results. So this is really important, and it will be mandatory to fill it in, so you cannot miss it. Next, describing a little bit more about the use of the substance. You have to describe the first level technical function of the starting substance in the material. So this is for organics and cementitious that you have to describe this, the technical function. In this case, I've just chosen monomer or other reactants. When you click on this, you'll actually have this pick list again. So for organic materials, there are 5 different first level technical functionalities, with one of them being the other. So again, if you don't find your the technical function from any of these options here, you can always have the other and then describe it. Next, you have to go in a little bit more in detail and describe the second level technical function. And this is now a little bit like with the plastics. So you have to go and see what kind of the actual functionality. So these, again, there's a pick list with different options. For example, fillers, extrusion aids, coloring agents, antistatic agents. And here is what you have to fill in, really what the actual technical functionality here is. And here actually I'm applying here for a monomer. So it's just monomer or other reactant is the first level. And the second level again is a monomer. Then there are 2 legal requirements here. So when you're applying for a starting substance for organic materials or cementitious constituents for the cementitious materials, you have to provide the maximum dosage that is used to produce the final material, and also the maximum concentration. And here it's actually, when we are applying for a monomer, of course, well, in PVC, apparently the conversion is quite high. So if you have one kilo of plastic, you'll need 90 grams of the polymer. So we have this hypothetical value here. But because the monomer is actually polymerized to a large extent, the max concentration of the monomer is really low here. Also, if you're applying for a cementitious organic constituent, you have to describe the monomers which are used to produce the polymers that are then used to create the generic constituents. Then there's an open text field called additional information on the concentration dosage, where you can give some more information if you see necessary. Then moving on from these to 2 fields which are related to the conditions of use. So there's a first field here called conditions of use, where you can describe whether or not your substance and material should have any restrictions as to where it can be used. Like in this case, well, should not be used in temperatures above 85 degrees, for example. And when you have these, you can also propose some text to be included in the European positive list, as Pano stated this morning. So, for example, here you can propose that this would be the text that should be on the European positive list. So, not intended for use at temperatures exceeding 85 degrees. Now, after we filled in this section called identity and use of the final material and product. We move on to describing the processing and internal structure here. And just to note, of course, there's no order in which you have to fill in Euclid. I'm just going through it now in this way, so that's from beginning to the end, but you can always fill in these fields, of course, in whichever order you want. So first, for organic and cementitious materials, you have to declare the processing temperature of the final material. So here you can give a number in ranges, temperature in ranges. So here it's from 160 to 200 PVC extrusion temperature, perhaps. So you can give a range of temperatures where your material will be processed or produced. Then there's the manufacturing process, which is a confidential field, which is a text field, where you can write in plain text, just in your own words, the basic manufacturing process of your plastic. For example, here is just basic PVC, compounded with components, extruded and or pressed in high temperatures, and then what kind of material you'll have in the end. And then there's a field after this one, information on the internal structure of the final material. So here you can give a short description, what kind of microstructure your material will have. And this is, of course, important because it indicates whether or not it's what kind of things could be migrating from it, if any. For example, here it's mostly amorphous with dispersed additive phases containing fillers as particles and modifiers in rubbery domains. So something short like this. After describing the manufacturing process and the internal structure, we move on to characteristics of the water. And this is most importantly, it's the temperature of the water, because temperature can greatly affect migration. So you should really describe whether or not your substance and material will be used in hot, cold, or warm water. There's also a field for including any other information that you think is relevant for the characteristics of water. For example, if you happen to know that the actual product will be used in some member state where the local water is something that greatly affects something. Now this is actually, I think we've covered the so-called easy part. And now we have to move to the slightly more complicated one, identification of NIAS other than impurities. And this is actually something that is quite scientific. So presumably when you are commissioning laboratories to do some work for you, perhaps they are also the ones who will actually do this analyzing of what kind of reactions may occur. But first, actually, there are two sections into which this is divided. There are NIAS other than impurities. This is now covering any NIAS which emerge from actually using your substance to create a material and then use the material. And then further down, there's another section, which I will go into in a little while, identification of NIAS from the use of monomers or other reactants. And actually, I will start explaining here from now, because actually what we are doing in this example is we are applying for a monomer, so the polyvinyl chloride, and then we are using that to create a plastic. So first, we have to identify whether or not in the polymerization process of the monomer, there would be any short chains, oligomers that are still residing in the polymer afterwards, which could then migrate. So first there's a question, are there NIAS from the use of monomers or other reactants? And this is, again, it's a simple question with a yes or no. So if you think that there are some NIAS, if you discovered in your evaluation there are, then you should say yes. If you say no, then you have to justify why do you think that there are no NIASes of any concern. So whichever way, you need to explain whether there is or isn't anything. Then there is this one open text field where we expect to have some kind of evaluation of the presence of any polymerized parts below 1,000 Daltons. So this really means the oligomers and the short chains which are able to maybe migrate. So Clicking on the help text here, it actually says describe the mechanisms leading to a presence or lack of the polymerized part below 1,000 Daltons in the material. So here we would expect to see some kind of explanation what would happen in the polymerization reaction that would really lead into incomplete polymerization, and how, to what extent, and what would be expected there. And you can explain in some words here. And then there's another field below that, the process that leads to the formation of the polymerized part below 1,000 Daltons. Again, clicking on the help text here, it says, describe the reactions of the prepolymer or polymeric starting substance, which may lead to the release of the polymerized part below 1,000 Daltons into water. So again, here we expect you to actually explain what kind of processes could take place that could be then result in some oligomers forming, which could then migrate into water. Then just after these theoretical evaluations, you also need to provide us with a molecular weight distribution report. And specifically, this should be focused on the polymerized part below 1,000 Daltons. So here is a field where you have to describe how your molecular weight distribution was conducted, what kind of methods. And then there's also a placeholder for the actual report, which would be what you would get from a laboratory who's conducting this measurement. Then from this report, you should be able to give us a number average molecular weight of the part below 1,000 Daltons and the range. So in this case, the average we have just put there 350 and the range is 200 to 1,000. And finally, there is a field where you describe the residual polymerized part below 1,000 Daltons and its concentration. And this again is a number that should come from the molecular weight test report. Then there's a placeholder for attachment where you can attach a more detailed description of all these reactions that may lead into the presence of oligomers in the polymer. And finally, here below, you have to identify any of the short polymerized parts below 1,000 Daltons. And this you can do by using the same reference substance entity that was used in other places of Euclid. So here is one example is vinyl chloride. Then you can click this and you can just come to your reference substance library and you can click one and add. And then within these reference substances, of course, there are mandatory fields. You have to provide us with a name. And I guess you have to provide also an inventory number and a CAS number, or at least one of these three. So you have to give sufficient identifications. And then now we are actually at the end of this analysis of the short chain oligomers. So the evaluation of the presence of NIAS from the use of monomers. So now I will actually go further up a little bit to the fields where we are evaluating the NIAS from the use and processing of your material. So here is the place, NIAS other than impurities. So these are the ones which originate from processing of the material and its use in contact with water. And again, here we begin with a very simple question. Are there any NIAS other than impurities? Where you can answer either yes or no. If you say yes, you have to then explain what do you think could be the ones, and then there's some tests you have to perform to show that either there is or isn't. Or you can also select no, and if you select no, then you have to explain why do you think there aren't any. For example, here in this case, we are applying for a vinyl chloride, which could react perhaps, but if you would be applying for something which is very stable inorganic, then maybe like a filler, maybe those would not react too much. So you could say that there's a no NIAS is formed. But in this case, it's a yes. And then again, there's this field evaluation of the presence of the NIAS. And this is now something that would follow the legal requirements. So the legal text is actually here in the help text as well. So describe the presence of the NIAS migrating from the material, taking into account at least the following. So consider physical properties of the substance, technical functions, its interaction with the matrix, water characteristics, and results of a screening analysis. So non-targeted analysis of migration test water to notice if there's any unexpected substances coming out. And here now we have written some example text here, how to describe this situation to us. So first there's physical properties, what could happen in this particular case, then technical function, this is here. And this is actually the thing where when you're producing your plastics, you have your monomer already reacted mostly to polymer. So it's actually here considered that it's a polymer and there should be, it's not intended to react anymore. However, when it's processed in elevated temperatures, there still could be some secondary reactions occurring. Then there's the interaction with the matrix. So this is the main polymer, should not react. Water characteristics, you should explain if somehow the water where it's used, they could affect your substance and produce any further NIAS. And finally, there's a place where you can provide results from the screening or the non-targeted analysis of the migration water. You can perform using whatever method is suitable and then produce if there's any results that show that there is or is not any migration of any unwanted or unexpected substances. Then there's a field where you have to describe some relevant reactions during processing. So here, for example, just made this example that when you provide, when you do processing of polyvinyl chloride into a plastic, you do this at elevated temperatures. There could be some thermal degradation, primarily involving dehydrochlorination or something like this. And then there is some description of reactions which may occur. So you have to, of course, consider your own case and think about what could happen. And then there's a placeholder here, relevant reactions during processing, where you can add some hard evidence in the form of thermal stability study, which would then demonstrate whether or not decomposition is expected at the processing temperatures, for example. Then after considering the processing, we can move on to relevant reactions during use. So this field is intended to be describing what would happen when it's actually in contact with water. So would it hydrolyze? Would some substances come out hydrolyzed or not? And what would happen? So this is, again, a free text field where you have to describe with your own words what would actually happen. And then to provide some evidence, there's a relevant reactions during use and a link to hydrolysis endpoint study. And just to point out that these two fields, the relevant reactions during processing linked to thermal stability study and relevant reactions during use linked to hydrolysis study, these are actually links to studies which are located in section 3 of Euclid. So the intended, the PhysChem properties. So I can just click here, the number 3. So here's 3.4, where the actual thermal stability study results should be reported. And for the hydrolysis, it's 3.12. So this is actually where the details of these studies would be. And you can add here a link so that when we are evaluating your applications, we can find all the study informations in a relatively easy manner. And also, as with the identification from the use of monomers, there's a placeholder where you can put your results of analysis of testing your waters by a non-targeted method, place to attach a document for detailed descriptions of what happens. And lastly, there's a placeholder for to provide identification for any identified NIAS using the reference substance data entity as for also for the other things from the use of monomers I showed. So just click on here, and if you don't have it here in your library, you can just create one and give the details. And these are then used for in evaluating the migration. So now we're moving towards the end. So we've described the material. We've described the characteristics, also the identity and use, then characteristics of the water, processing internal structure, identification of NIAS to the fullest extent we can. And also towards the end, there are just 2 places, so there's additional information. So this is a place where you can put any descriptions or information you think that should be relevant, but you don't find any dedicated places for these to be included, so you can add them here. And finally, at the very end, there's a declaration. Is this use the worst foreseeable use for any potentially relevant chemical species? And again, this is a simple pick list with either yes or a no. So if you think that it is the worst foreseeable conditions of use, then you should have yes. And if it's no, then no. And usually when there's only one intended use document, then we would assume by default that it's always a yes. So the only one that is declared, that should be, of course, the worst foreseeable use. And here, just to maybe finalize this one, is to say that we only can evaluate what we have. So it would always be in the best interest to provide us as much detailed information as you possibly can, because then it's easier to come to any conclusions based on it. This is now for the organics, and then I will just go on to the metallics. I will choose a metallic substance. So I would say that the intended use section for the organic materials, it's actually can be quite complicated because of the NIAS analysis, but for metallics and enamels, it should be quite easy and much easier. And it's more like just declaring things. So here we are now in a metallic alloy dossier where I'm demonstrating the use of the metallic alloy. So again, section 4. And also here at the top, there's the section characteristics of the contact material with only 2 fields. So of course the material type here is metallic materials. Again, only 4 options, and you choose the correct one, so metallic. And then importantly, you have to declare a metallic material category for this composition. So here I've chosen copper zinc alloys, but if you click here, you can have a pick list, and then you can see that you have all the existing metallic composition categories in this pick list that you should also find from our guidance. And also now there's also at the very bottom, there are these options, modify existing category or new category. So if you are applying for an alloy for which there is no suitable category at all, you can create a new category, and then you have to choose this one. And of course, you need to describe your category then. Or if you have something which is almost good for or belonging to a category, but some compositional ranges could be slightly outside, you can choose modify existing category and then propose how you think an existing category should be modified. So that's easy. So 2 fields and 2 pick lists. Then we move on to the identity and use of the final material and product. And again, here first, just declare whether or not this will be used in a surface layer, so whether it's a plating or not. In this case, it's a no. And again, this is just a pick list, yes or no. Then choose the type of product or component that your alloy would be used in. I've chosen fitting here, but it's the same list essentially as for the organic material. So just a pick list where you can pick more than one option. I've just chosen fitting. Then you can give a detailed description of the final material or product in use. So there's a free text field where you can just freely describe where exactly your alloy would be used in. Then there's a placeholder for attachments if you need to have anything else to describe the use. And then something that is quite important and will be mandatory to fill in, of course, is the product group of metallic material. And this here now is a pick list with 4 different options from A to D if you are using something in pipes, 100% exposed surface, from B to D if it's 10% exposed surface, C to D, and these A, B, C, and D are product groups, of course, which are explained also in our guidance document. And this is very important to choose one, and you cannot submit without choosing one. This is, of course, the A factor also, which is then used to calculate your CTAF values when you're assessing the safety of the material with the migration test results. Finally, there are 2 fields here, conditions of use and proposed conditions of use for inclusion in the European positive list. And these are the same as for the organic materials. So if there's any particular conditions of use, like do not use in contact with ammonia or something, you can describe them here. Then for metallic materials, also there's a placeholder for describing the information on processing and internal structure. So processing temperatures, and then the basic processing steps like here. So you melt and alloy your material, and then you do whatever forming operations, in this case extrusion, cut, and forging, and then how the actual final products are being made. And then there's this field where you need to indicate the basic internal structure of your final material. So here's just a single phase alpha brass with FCC structure. And then also, in addition to the structure and processing, you have to give us the characteristics of the water. So basically the temperature of the water that your material will be used in. In this case, this will be something that is in contact with cold water. And again, there's a field for any other information. But after these few fields and this very short description of the intended use, there's only a place for the additional information in case you need any, and the worst or non-worst foreseeable use. And for metallics, basically because we only expect one declared intended use to be given, we sort of, by default, we consider that this should always be a yes here. This is now the end of the intended uses. So thank you very much for your attention. I hope you found some of this helpful. So next, in this session now, I'm going to talk about how to fill in the EUCLID study record for the electrochemical test. So electrochemical test is a basic corrosion measurement technique, and when applying for the European positive lists, it can be used to substitute migration testing for certain alloys which are passive or they have a protective layer and do not corrode very much. I only have a few slides to show to give some basic details, and then I will again demonstrate in Euclid how this study record should be filled in. So as said, the electrochemical test can be used instead of migration testing to substitute for some passivating metallic compositions. Of course, you can do electrochemical test for any metallic alloy, but it probably won't be passing the criteria. Only for the passivating alloys, it's probably going to pass the acceptance criteria. This is, of course, located in section 5.2 in Euclid, as shown on the screenshot. So section 5 is the data on migration of the substance and electrochemical tests. And then there's a section 5.2, which is the electrochemical test. And that's where all these records of electrochemical tests should be provided. The contents of the test study record, this is again something that is specific to Drinking Water Directive. It does follow the same structure as many testing study records in Euclid. So there are these sections, administrative data. And there's this very important section called data source. And we would expect that when you are conducting an electrochemical test by a laboratory, the test report that you get should be attached in this place so we can find it easily. Then there's a section called Materials and Methods, and here are some Euclid fields where key information from the test report should be inserted. So in this section, basically what the Euclid fields are about, they are about the actual conditions and information that should be coming from the electrochemical test report. So there's no additional information required in the field that should not be in the report already. Then after materials and methods, there's also this section called results and discussion, where we expect you to put in the final, the main results from the electrochemical test, some curves and so on. And finally, there's a section called overall remarks attachments, where some additional information can be given as necessary. But here is actually all the slides for this. So now I will move on to demonstrating in Euclid how this would work. Right, so here I am back in Euclid, and now I have the metallic materials dossier here open. So I will go on to my substances and select mock dossier for passive material, where I have created data for the electrochemical test. So just label this record nickel chromium 730, just a hypothetical name, aiming to be realistic in a sense, but it's just make a disclaimer that this is hypothetical data, of course. So first, at the very top of this record, there's this section called administrative data. This is also the same kind of section that is found in the migration. So hopefully it bears resemblance. And the first field here is the field called endpoint. And this is actually something where you need to select the kind of information that will be given here. Then there's only one option. So experimental electrochemical test. So there's not much of a choice here. Then you can indicate here when the study was conducted. So some basic practical details. And then also there's this one field called reliability, where you can make a conclusion here already at the beginning, how good job you think it was done during this test. So this is actually something that there's a help text where it is explained what these reliability scores mean. So there's 3 different options to choose from in a pick list. So 1 would be the best one, reliable without restriction, 2, reliable with restrictions, and 3, not reliable. And of course, if you would conduct this electrochemical test following the legally mentioned standard, the EN 16056, it would be done by an accredited laboratory. It should be mostly 1, so reliable without restriction. And here actually, as said, clicking on the question mark, there's an explanation in the help text when should you choose which reliability factor, but mostly we hope it would be 1. And then here is the important place that I was mentioning before, so data source. So this is now a Euclid data entity where you can insert details and attach the actual report. So basically clicking on this field reference, I can go into this data thing where you can provide general information and also attach things. So basically the type of reference you can choose from different types. And because this is a study report, of course, this will be a study report. Then you must give a title, author, year, test facility, report date, report number, who paid for it. And then very importantly here at the below, there's a placeholder for attachments. And this is the place where you should really attach your test report from the laboratory that they should provide you with. And this is very important and probably made mandatory, so you cannot submit without this. Yeah, I'm not going to save. So this is very important. Then there are fields where you can claim who's owning the data and so on. And then moving on from data source, one also equally very important thing to fill in is this test guideline. So here is the place where you need to give indication what kind of method or guideline was used to conduct the electrochemical test. For most parts, it would be good if it would always be this EN 16056, as this is really the legal requirement. And here is actually a pick list with only two choices. So this EN 16056 or other, in case you had some very strong reason to use something else than this. Then you can also indicate which version of the standard you've been following, the most recent ones, whether or not you've deviated, and then a qualifier, whether or not you follow the guideline exactly or there were some deviations or something else. But mostly the row as it is here, that would be really good. According to guideline, following this standard, most recent version, no deviations, that would be good. Then there is a field in case you use something else that you should describe the principles of the method, but this is not relevant in this case. Then again, something very important that we expect from all the studies in section 5, the other quality assurance. And the other quality assurance means basically that the legal requirement is that any study conducted under the Annex 4 of migration should be conducted following the ISO IEC 17025 quality standard. And it would be really good if the laboratory that was doing the test would also have accreditation for this particular standard under ISO 17025. But here you must indicate which quality assurance was followed. Mainly it would be the ISO 17025. There is an option to fill in other, but mostly it should be ISO 17025. And then you can give remarks, like here, for example, we've written just here the test conducted by ISO 17025 accredited laboratory, and then attachments for accreditation certificate. And this is, again, another important point. So when you declare the quality, so mostly ISO 17025, there has to be also an attachment of some kind of documentation demonstrating quality. And mostly the easiest way to do this would be by giving the accreditation certificate, which would then contain also the scope of the accreditation, and it should include the relevant testing and analytical standards. Well, then now, after you've declared the quality, which is easy to do, then you must describe us the test material using, again, one of Euclid functionalities called test material data entity. So you can click on this, and then here is a place where you can generate and create your test material. And here just describe this alloy that was tested. So I've given it a name, and then there's some constituents and impurities, what it's made of. So basically nickel chromium alloy, and the concentration. You can also give other information as you see necessary. But this is to describe really what you were studying, what kind of alloy, and it should of course match with the alloy that you declared in the intended uses. Then there's a link to the analytical details, so test piece composition. And this is something that would take you to section 6, or the analytical methods for migration and material characterization. In Euclid, we have ordered this so that section 5 contains the migration data and results, and section 6 contains details of analytical methods that are used to analyze the test pieces and the migration water. So this here is a link to the actual the analytical section record which contains details of the analytical method. And I will demonstrate this section tomorrow in more detail. But it's important to make this link because you have to analyze the composition of your test pieces always. Then after describing test material, there are fields where you can describe the study design. And these are, of course, information that should come from your test report that you have attached in the data source. So you can describe test cell geometry, also include any attachments describing it more, whether or not it's according to 17475, which gives general guidelines on conducting electrochemical tests. Then you have to describe the electrodes that you use. And of course, if you follow the standard EN 16056, you should always have your test sample, and also you should study also this 14405 or 316 stainless steel as a reference material. And then you can also indicate your reference electrode that was used in the study. And this is something, again, you don't have to write, but you can just choose from a pick list the electrode materials. Then after describing the cell geometry and the electrodes used, you need to describe the shape of your sample. So in this case, it's a plate. And again, there's a list of pick list where you can choose different options like sheet or a plate or other if you cannot do sheet or plate. And again, these follow the guidance given in the standard. So it should be either a sheet or a plate whenever possible. Also, the dimensions you can write here. So this is again from the standard. Surface preparation, also very important. And in this case, actually the EN 16056, it does describe a specific preparation procedure for the surface, which papers to use to grind it and so on. Also, storage before the test is important. And then, of course, what kind of surface area you have exposed in your test. And again, this is something you can choose from a pick list, and it comes directly from the standard. Then after describing this, of course, it's really important to describe your test solution. This is also something that is specified in the test standard. So first describe the preparation, just in a few words. Indicate the temperature, the pH, a chloride content before the test, because this standard actually stipulates that you should use chlorinated water. Also, you have to give conductivity and volume of solution in the test cell. Then there are fields about the test procedure, so the test temperature, pumping rate of chlorine solution. Also, you have to indicate the free corrosion potential after 60 minutes of stabilization, as this is a requirement of standard. You start your test, you immerse your sample in the solution, and then you measure the free corrosion potential after 1 hour of stabilization. And then you have to also indicate whether or not this was constant or not. Then you need to indicate the type of potential increase and also how much time you're actually taking before starting the test. Then select the type of potential increase. This can be either stepwise or constant. You just chosen constant. Then indicate the polarization rate, of course, in millivolts per hour, use 20. This is a number field. Termination current density, of course, this is where you record whatever the current density was when you terminated the test, as is stipulated in the standard when you have to cut it. And then any further details on the study design you want to give. And then also there is any other information on materials and methods, including tables. So now, after describing the key elements of the test, finally you have to give some key results here in Euclid. Also, of course, these would all be included or should be included in the test report that you would attach in the data source. So test number, test conditions, plot of the applied current density versus applied potential, so the polarization plots. The pitting that you noticed, or the millivolts pitting potential. Chloride content after the test, as this is again requirement of the standard. Whether or not there was pitting or crevice corrosion. And also you can indicate already here, is the measured pitting potential higher than the measured free corrosion plus 500 millivolts? Yes or no? And this question is actually something that will tell you whether or not your alloy would be acceptable by this test, because the requirement is that the pitting potential has to be 5 millivolts higher than the free corrosion potential. Also, there's a placeholder for any other information, including tables. So here I've just made up this table. For example, if you do 3 tests, you could have the mean values, and this is the results, and you can also present them like this. Finally, there's a placeholder for overall remarks and attachments. And here's just an overall remarks of mean pitting potential from 3 measurements is 890 millivolts. And then lastly, this time in the place of attachments, very importantly, here we have attached the ISO 17025 accreditation certificate. So as said, when you indicate your quality standard or system followed, you need to also include some documentation. And the easiest way to do this would be to use accredited laboratories and attach the certificate here. Maybe in future versions of Euclid, there would also be a more dedicated place for this attachment so that it won't be so difficult to insert it. But this is now the electrochemical test study record and what to fill in and how. I hope this was helpful, and this is now the end of this section of the workshop.
Hello. I think we are back. We will try now to show on the screen the questions we have been receiving since the morning. Thank you for your patience. We'll try to take them all. As I mentioned before, we'll do our best. Some questions may need additional thinking from our side, and the most authoritative response will come in writing and will be uploaded on the event page on our webpage. I hope you can see me well. I will try to move now to the web page, where we show the questions. Maybe if I do this, it was not the page I want to do. Give us a second. Oh, this one. I hope this, yes. Right, this is the list of questions we have received through Slido. There is a total of 17 questions, if I can read the screen correctly. We will be highlighting perhaps randomly at the beginning questions to try to answer, like we have highlighted one from Mr. Frost. You have the opportunity to give a thumbs up to any question if you feel that it's something you also have an interest in, to try to push it a little bit up through this thumbing up, so we can see that there is more interest in a specific question. We can take it next, but I think we have sufficient time to probably try to take all questions, so I don't think this thumbs up will make a very significant difference. But if you do see something that you like, please take the time to give a thumbs up. There are a number of colleagues, their cameras are on in the same room. You can, at some point, some questions will be addressed to them because they are more relevant or we have more expertise in specific topics. So I will start with the one that we have randomly highlighted. Is the one that I hope it shows on the screen, is this one in yellow background from Adam Frost. How is this handled if 2 different participants create the same base material but with different effects? The question is not very clear, but my interpretation, and Mr. Frost can send another question or clarification through Slido, is that what happens if you have 2 applicants who create dossiers for the same substance or composition, but the contents differ? Potentially, you have different toxicological properties or something of that sort. The Committee for Risk Assessment, RAC, will issue a scientific opinion on applications based on all available information, and that includes other applications that may have been received for the same substance. There is also the possibility, according to Regulation 369 of 2024, to group applications together because, for example, they are for the same starting substance, it may be relevant to the same impurity and so forth. There is a list of situations, of scenarios where such grouping could be made. So it is entirely possible, and actually we will try to do this in practice if, for whatever reason, there is no collaboration among interested parties and we have 2 or 3 applications for the same substance, to send them together to RAC, so RAC to take all the information into account and reach a conclusion what should be the correct outcome, whether the substance has this toxicological effect or the other effect. So the simple answer to this question is that we will take this information into account together to reach the most scientifically robust conclusion. I hope this was useful. If Mr. Frosch, if I misunderstood the question, please send something in Slido and we can take it back. I think we will have the time to do that. We can move to, well, all of them have 1 thumbs up, or at least the top of them. I'll go to the next one. Let's highlight the fiber reinforced one. I will read it out, and this no, it has another one has been reinforced. Sorry, yeah, I thought it was the fiber reinforced, but something else came up. It's not a problem. So another one, which probably I will take myself. What is the purpose of requiring each participant to create a dataset for base materials such as zinc, copper, etc.? Shouldn't these materials already be included in a database along with their effects and be identified by their EC number or CAS number? I assume the question relates to creating the different data sets that we showed earlier, that we attach, we link rather in section 1.5 of the main data set. We, as an applicant, you need to identify the relevant chemical species. There may be multiple ones. It could be some ones that we know very much what their hazard they are, or we don't need any toxicological information because we have a parametric value or an SML. Examples are zinc, copper, etc. However, there may be cases where we do need toxicological information in order to generate, you as an applicant, to generate an MTC tab value. Euclid is not that intelligent to understand that now I have zinc, which is a very simple case, so I should not expect to see anything about zinc. You simply need to create a dataset for every relevant chemical species and link it in section 1.5 of the main dataset. As you saw for zinc, and the same will be for copper, for example, I'm using the examples that are given in the question. These datasets are practically empty. We do not ask for any additional information to be provided. You just need to create a reference substance. The reference substance, you would have to create it anyway when you are preparing the composition of your, I presume in this case, of a metallic composition in section 1.2 of the main dataset, where you need to explain that it's a copper zinc alloy that has copper to 50 to 60% and zinc the remainder, and aluminum 0.1 to 0.5. In order to create this section 1.2, the composition, you need to create reference substances for each one of these elements I have just mentioned in my example. So you are already creating this reference substance for your main dataset. You simply need to create an almost empty dataset for these elements. It is not really much work. Believe me, you will have much more work on other fields to put into this process, but Euclid needs to have datasets for every relevant chemical species. For zinc and copper would be very, very light in content. We can move to the next one. We can take the one with the 2 thumbs up. And this is something to be answered by my colleague Nico, my Nico colleague. Nico, please.
Thank you. So the question is, could you explain how fiber reinforced plastics are handled? Specifically regarding the fiber reinforcement, does the fiber reinforcement need to be listed separately or as part of the composition along with the matrix plastic? The short answer is that yes, the fiber needs to be listed separately. So that would be then your starting substance, which you are applying for. If in the case of plastic, of course, it's an organic material. So describe your plastic material in the intended uses. And you have your fiber reinforcement as the actual starting substance. And then you describe your plastics where it's used, and then you do migration testing and look how much migrates or something like this. But that would be the short answer, yes. So separately, it has to be listed.
Thank you, Nico. We can take the next one that has 1 thumbs up, again from Mr. Frosch. I will read it out, and this one will go to, I think that's the one we saw before, right? It's exactly the same. It's related. Is it different? I will read it out just to understand myself. What is the purpose of requiring each individual Euclid account to create the base materials for a composition? The properties of the base materials, such as copper, nickel, etc., unknown. Nuria, you can take this.
Yeah. Thank you, Panos. Well, the purpose is that in principle, the applicants should know best the substance they are applying for. I guess to base materials, you refer to the reference substance. In principle, for each Euclid account, when you haven't worked on, you haven't prepared any data set or any reference substance, it's completely empty. And then, as I explained, you need to create each of them. For the applied for, and then you create an inventory that can be used for the applied for entry, for the constituents, impurities, and for the relevant chemical species. And the only help or the only pre-filled stuff that you can have more readily available is the EC inventory field, that when typing the EC number, you get the CAS and the name. But the rest of the information, like the molecular information and the structural information of the substance, unfortunately is not available. And even if for copper and nickel, it seems quite straightforward, it's the same for all substances, and it's not available. You need to do this work, but it shouldn't be that massive work, because once you have done it, then you can use it across the dossier and also in other dossiers. So if you are creating a new data set for another application, you can reuse that the same reference substances for that purpose. I hope it was clear. If not, please provide some other additional question. Thank you.
Thank you. Thank you, Nuria. Indeed, the work you do in Euclid stays there for you to use in the future. And if you want to create a new dossier for another application, indeed, the reference substance for copper will be there for you to use if you have another copper alloy. Let's move to the next one. The top of my list is Alejandro's question. I understand that additional toxicological information is required for constituents not listed in the European positive list or without an assigned MDC tab value. But could you please confirm whether a relevant chemical species entry must be created for all constituents of the EUPL entry or only for those requiring additional toxicological information? Okay. Let's take this one step at a time. Your composition in enamel, let's say ceramic, may have 20 constituents. Okay, you do need to present them all in section 1.2 of your main data set. So in 1.1, you call your composition enamel, let's say, or glass, or whatever it is, borosilicate glass. In section 1.2 of the main dataset, you need to provide all the constituents that meet the concentration thresholds in Annex 1 of Decision 365. So you are going to have there the silicon dioxide, the copper oxides, iron oxides, molybdenum oxides, titanium dioxide, whatever. But all of them that meet this threshold of Annex 1 of the Decision 365, you provide them there. And for each one of them, of course, you create a reference substance, the copper oxides and the titanium oxides and whatever. Now, to understand out of all these 20 in my example constituents, which ones are the relevant chemical species, you need to go into section 1.4 of Annex 4 of Decision 365. And I'll have it on another screen here. I'll try to read it out just to make the point more clearly. It says that to find, it says, sufficient information on the determination of the migration of all the following substances, at least including the information set out in Table 1, shall be generated. I skip a few sub-points. I'm going straight to the inorganic compositions. And it says, each inorganic composition, constituent, and impurity identified in accordance with points 132 and 133 in the table of Annex 1, unless the inorganic composition constituent is carbon, calcium, fluorine, iron, magnesium, nitrogen, phosphorus, potassium, silicon, sodium, tin, or zinc. So these ones are not relevant chemical species. You are not supposed to test migration for those. So going back to my example, you start section 1.1 of the main dataset, you put enamel. In section 1.2, you have all your constituents, your copper oxides, the zinc oxides, the silicon oxides, or whatever. But when you want to find out which are the relevant chemical species, you need to look into the legislation, this section 1.5 and its sub-bullet point C, that explains that certain elements in organic compositions are not of concern. So you may have constituents you declare in section 1.2, but you do not need to create data sets for them. Okay. Now you do need to create data sets even for things that do have an empty setup value, and you don't need to provide toxicological data. You saw the zinc example for metallic compositions that we presented earlier, but it's not something that it will take you too much effort. So to recap, if you want to know the relevant chemical species for inorganic compositions, please look into the section 1.4 of Annex 4 of Decision 365 of 2024 to find out which ones you can exclude from your list of relevant chemical species. We can take the next one, which is, I think that will be for Vesela. Can those Euclid data copy from each dossier, not need to fill in again by hand? I think the question is, can we reuse information from a rich dossier in order to create a Drinking Water Directive application? Vesela?
Yes, thank you, Panos. The short answer is yes. The information from rich dossiers can be reused for the drinking water application. And there are two possible ways this to be done. The first one is to reuse the entire dataset that's been prepared for REACH and to create a DVD application. This would require to switch the working context from REACH to the DVD specific, to the DVD application, and then you would also need to add the DVD specific documents, the one that are not relevant under REACH. The second option would be to use the copy data form functionality, and in this way you could copy the relevant information from REACH to the Drinking Water Directive templates. What I also want to mention is that doing this, so the technical requirements or how to do this, technically it's on one hand. On the other hand, if you are using this information, you also need to ensure that you have an access to it and the rights to use it, especially if you are not also a REACH registrant. And the final thing that I also want to mention here is that just to remind you that under REACH, we are dealing with substances, and under the Drinking Water Directive, we are dealing with relevant chemical species. So before reusing any information under REACH, you have to be sure that whatever you are copying and pasting, it serves the purpose of the drinking water application. So I hope that that was clear. Thank you.
Thank you, Vesela. I hope that was useful. Let's move to the next one as I see it on the list. If an organic material is used in different uses or final products, how migration tests shall be done on this organic material, on the organic substance itself as such, or every final use must be tested for this substance? Nico?
Thank you, Panos. So I guess here this question refers to one starting substance that is used in one material in different kinds of products. So here, actually, the migration testing shall be done on a test piece made from the material, and it should be designed in such a way that the test piece is the worst foreseeable case for the material, meaning the one where the migration is the highest, and this would indicate something where the concentration of your substance in the material is probably the highest, and also maybe the material has the lowest density or something in the structure-wise, so that most would migrate. The migration test here is a laboratory test where you can use a shape of test piece where the surface to volume ratio is what you want and very high. Between, I think there's ranges in the standard before between 5 and 50 or something. So what you would need to do here is test your substance in the material that you are using it, and then you only have to do one migration test. But then if you are using the same substance in the same material, which is then used in different products where the shape or the contact surface is varying, then you can use the conversion factors found in the product groups and tables to calculate what would be the CTAP, and the acceptance on the European positive list would be then done according to the worst foreseeable use, or the case where the CTAP would be the highest. And when this is accepted with something like this, then anything that is of a lower risk would be automatically acceptable as well, because the CTAP value would be lower than the empty CTAP. So you only need to do one migration test for this particular substance if it's used in different kinds of products. The number of products is not really that relevant, because based on the migration test and the conversion factors, you can calculate your CTAP for different products and see where the usage can be then acceptable. I hope this helps.
Thank you, Nico. Let's move to the next one about bismuth. I see, Nico, will you take this? I see your name, but I will read it out and then I'll pass it on if you're happy to take it.
Sure. Yeah.
So how is the, sorry to jump ahead of you while giving you the floor. How is the listing process for adding a bismuth containing alloy to the European positive list? There is no empty setup for bismuth in the EUPL. Do you first have to apply for the inclusion of an empty setup for bismuth in the EUPL and then the listing of the alloy, or can both be done in parallel?
They will be both done in parallel. So you would apply for your alloy as you would for any alloy. So you declare your composition, the metallic material composition category. In this case, I guess you would have to create a new one. Then you do the migration test, and then because there is no empty CTAP value for bismuth, you would have to look how much it migrates and then generate toxicological data according to the migration tiers as for an organic substance. And then based on this data, you would then determine what is the empty CTAP. And then this is what you would use to assess whether or not it migrates below or above it, and then have your alloy accepted. But yes, indeed, you would apply as for any alloy, just that you would have to really analyze the bismuth as well from the migration water. For metallic materials, section 1 of the Annex 4 of the decision 365 describes which elements are always relevant for metallics for which migration information must be generated, and bismuth is always one where you have to do this. I hope this helps.
Thank you, Nico. Yes, do it in one go, both of them. The next one, I move to, I think I should have answered this, but I will take it once more. It's on the problem. Alejandro is asking, I would like to ask for clarification regarding the term relevant chemical species. Should this be understood as referring only to those constituents which are not included in the EUPL, or for which we do not have an empty CTAP value, or does it refer to all the constituents listed in enamel composition? The answer is neither of the two. The answer is somewhere in the middle. Again, I would refer you to section 1.4, the beginning of Annex 14. it is not only a relevant chemical species, not only what is missing an MTC tab value, and it is not also what is simply listed as a constituent in the composition. The relevant chemical species is defined in the legal text, and it is whatever it is in the composition minus, again, I'm going to look at the other screen to read it properly, carbon, calcium, fluorine, iron, magnesium, nitrogen, phosphorus, and so forth. So to give you an example, take copper. If you have copper in your inorganic composition, copper obviously does have a parametric value. You don't need to provide any toxicological properties. It's easy to generate an MTC tab. So copper is a relevant chemical species. You must measure it in the drinking water. You don't need to provide any toxicological data, but still you need to provide a data set, almost empty data set, attached in section 1.5 of your main data set. So I hope this is becoming clear. I know there is some confusion. The important point, want to know what is the relevant chemical species? For metallics and organics, look into the legal text. You need to look there because it clearly says this is relevant, the other things are not relevant, or it tells you which ones are not relevant. Rather, it works like this. You will know which ones are not relevant. The legal text is your guide. The next one must be for Nico because it was about the presentation on electrochemical test. Is it mandatory to attach the original study report?
Short answer, yes. So the data source data entity is the place where you should attach the study report from the laboratory doing the test. I would state though that there's a section where you must attach it, which is called sanitized version. So before you attach this report, you should really sanitize it for any confidential information. But yes, you must attach it.
Thank you, Nico. The next one is it jumped up of I was looking at something else. Again, it's about electrochemical test. Is it mandatory to include the certificate for quality standard ISO IEC 17025 if it is not included in the attached original study report? Nico?
Yes, because when you indicate the quality that you follow, which for most parts should be the ISO 17025, you must also attach some documentation which demonstrates the adherence to this quality. And I wonder because usually, at least for example, the accreditation certificates, they are separate files or separate things and not maybe always included as such in these test reports. So you would have to provide them separately, but if they would be included in the original study report, it doesn't hurt, but we would like to have them separately. Thanks.
Thank you, Nico. Let's move to the next one. Again, for Nico as well, with regard to intended use and water temperature, if the material is used in both cold and warm water, which is typically the case with metals, do two intended uses need to be specified?
No, because in one intended uses document, you can indicate the water temperature as a range. So you can indicate from the lowest to the hottest. So only one is needed and you can indicate the range.
Thank you. Thank you, Nico. The next one, this is probably for me. How about inclusion of substances to the European positive list of the drinking water listed by other positive lists present in the EU, like, for example, the 4 member state positive list for organic materials? The European positive list was compiled in 2021 from national positive list and the food contact materials for polymers positive list from regulation 10 of 2011. Back then in 2021, the members of the 4 MSI initiative, France, Germany, and so forth, they did provide that list. So what was available in the 4 MSI positive list back in July 2021 is in the European positive list. We do appreciate that There may be some entries in those positive lists of the 4 MSI that were added after July 2021. These have not made it into the European positive list, and for those entries, there are some transitional provisions that apply, but the bottom line is that you do need to make an application for them to be added to the European positive list. But the vast majority of what the 4MSI has been approving over, I don't know how many, 15 years they were working on that harmonized approach, it has been included in the organic materials European positive list. If you need to come back with something more specific on this question, yeah, please do to add your question and we will have the time to take it. Let's move to the next one, which maybe a little bit relates to the one that Nico responded to last. And I would like to know what the answer is to this, because I wonder what Lorenzo has in mind when it says, is it possible to insert more than one use for a metal? Don't know what 2 uses you would have, Lorenzo, but yeah, Nico maybe will explain for me to understand more.
Sure. So in case this more than one use refers to more than one intended use record in Euclid, sure, it's possible, but you don't have to do that. And also within one uses document in Euclid, you can declare more than one use, just indicate more than one product types where your alloy will be used. But then again, the evaluation of the acceptance of the alloy, this happens by product groups. So it's not by individual product, but rather how much of the surface of your alloy is exposed to drinking water, and then certain products which fall within this exposed surface. And this is how the evaluation is done. So you don't need to indicate many uses, just indicate the highest exposed surface according to the product groups, and that's sufficient for us. So thanks.
Thank you, Nico. Also, to add to this exposed surface is classified in letters A to D. You may have obviously the alloy being used in products that fall under product groups D, C, B. Then you make an application that covers B to D, and the assessment, indeed, as Nico said, will be done on the basis of the highest exposed surface, which is B. If there's something else on this, Lorenzo, please come back with any follow-up question if you need some additional clarification. Let's move to the next one, which is for Nico again. How catalyst and polymer making like PVC is evaluated? As an impurity or NIAS? Nico?
Yes, so this is a bit of a trick because impurity, in fact, is a NIAS, as we have defined in the guidance and also I think in the legal text. The NIASes, other than impurities, they are the reaction products which take place when a material is produced. And also if you're manufacturing a polymer, then the monomers and the polymer reaction aids. And actually for catalysts, what it can be is in fact an impurity because, I mean, catalyst is used in the polymerization process in plastic production. Well, it can be then carried over to the final material, the plastic, as an impurity. Of course, it can migrate potentially. So there it would be an impurity, but when you are listing the catalyst, you would apply for it as a polymer production aid. And then it would be really an applied for entry instead of a NIAS or anything like this. So I hope this helps.
Thank you, Nico. I can stay on the line because the next one is about migration. Migration test, which OECD TG standards?
None, I would say. The legal text specifies standard tests, which are European standards, so drafted by CEN, the European Association for Standardization. There are specific standards mentioned for each material type. So those would be the reference points for evaluating any testing done. And I'm not even sure, actually, I would have to check whether or not there are any migration testing guidelines from the OECD. But mainly you should test according to European standards.
Thank you, Nico. The OECD TGs are for toxicological assessment. The next one, metallic compositions. This is for Nuria. What is the difference between the boundary composition and the reference material?
Thank you. The boundary composition, it refers to a term that is used in Euclid and the drinking water for metallic, sorry, and the drinking water for metallic compositions, it's should be used to report new metallic composition categories and modified composition categories. Whereas the reference material should be reported in the same section, but with type of composition other. So we are talking about different elements here. Boundary composition refers to Euclid, and the reference material should be reported under other type of composition. You can, if you have a look at the slide 59 of my presentation, in brackets, you can see the type of composition field in Euclid. No, sorry. The type of composition is without the brackets, and what is expected to be provided under that type of composition is with a bracket in the table. So maybe it's clearer to see it directly from there. So boundary composition in Euclid should be used to report metallic composition category, and under the other type of composition, the reference material should be reported. It's a bit tricky to explain, but I think from the table it should be clearer. Hope it clarified your question.
Thank you, Nuria. Let's move to Alejandro's next question about the dossier header. Could you please clarify which migration tier should be selected when working with the applied for entry for an enamel listed as EUPL 2029? We have set up values for the individual constituents, but not for the enamel as a whole. That's a good question, and perhaps I should have shown in the live demonstration. In the case of metallic and inorganic compositions, as I mentioned a couple of times already, the compositions themselves are not relevant chemical species. They are just mixtures that may release copper, zinc, aluminum, titanium, whatever is going to be released. So because the enamel itself, it's not a relevant chemical species, you do not need to provide any migration tier for the enamel. So if in the dossier header, you open the dossier header in the field material type, you select metallic composition, metallic materials, or enamel, ceramic, and other inorganic materials, then that field that follows, which is migration tier of the applied for entry, will not be there for you. You do not need to provide a migration tier for enamel. But thanks for spotting this. I could have taken a little bit of extra moments to give you the different possibilities depending on the material type. Let's move to the next one, and I'm happy to take this as well. Is it possible to publish a general timeline on the website, including the delivery dates for materials and adding also some planned dates for releasing additional guidance documents? Maybe we could do this, but I can explain a little bit the timeline now. I think that there was a plan at the end of tomorrow to explain this, but why not do it now? We have first the guidance documents. I mentioned before we have 4 guidance documents. The 2 are for the application process. One is how to test substances and compositions. The second is how to do the human health and risk assessment. Okay, they are very large, very large. They are substantial documents. They are more than 100 pages long. You really need to take a look into them if you are planning a new study, a new laboratory study for migration, toxicological properties, and so forth. The third volume is about the scope of applications, and the 4th volume is about notifications of intention. A 5th volume is from JRC, which explains what samples you need to send to them after the Risk Assessment Committee, ECHA, issues an opinion on your application. This is really far into the future, and I do not want to go into too much detail about it. So we have these 5 documents, 4 plus 1. We are currently looking into refreshing the guidance documents, and we expect a new version of them with small targeted modifications, particularly for volumes 1 and 2, to be available in July. In July this year, we expect to have this ready. So, but generally, the bulk of the information, advice, and the guidance is already there. You can go and read these documents. They are still very, very important and useful. The next support document we have is the so-called practical guide. I mentioned this already, and I will explain this tomorrow as well. There is this DWD infographic on our website, what we internally, colloquially, we refer to as the metro line, where it shows the entire process from starting from the very beginning to understand what's going on about Drinking Water Directive, the European Positive List, all the way to preparing a notification, submitting a notification, then preparing an application, submitting an application, doing us to do the accordance check. There is a consultation of interested parties. RAC will issue an opinion. The Commission will take the opinion to reach a decision, and at the end, the European Positive List may be updated to add the substance, remove the substance, and so forth. This infographic is being developed gradually, but right now what it contains the most important parts, which is from the very beginning, when you start to learn what the Drinking Water Directive is about, all the way to the submission of your application. And so in the coming months, we're going to add the accordance check description, the consultation of interested parties description. These are not very important right now. Your more important task is to understand how to notify and how to apply. This advice is now there in this infographic. There will be a link to this. I think there was a link in the early slides this morning. There will be another link tomorrow. Behind this infographic, there's a practical guide. The infographic contains a limited amount of text, not to obviously make it too heavy for somebody to read it on the screen. So in most places in the infographic, you click on an option to see how do I create an ECHA account, for example. There is a phrase or two for you to be given some immediate understanding of how to do this task. And there's usually a read more link at the end of the sentence where you click that and then a PDF document opens, and this is the practical guide. The practical guide is developed alongside the infographic. Every time we develop a new part of the infographic, the practical guide includes more background information. The practical guide is supposed to be something very, very practical, as the name says, to give you a quick snapshot of what you need to do and guide you to certain places, to tell you need to look into guidance volume 1, section 5. You need to go to that link and do this. You need to access the industry portal to submit your notification by using that link. So it sends you around to different things, but it's very practical and it's very concise. It helps you. If you need to read one document at least, read this. You can start from this because it really guides you to different other documents. So we have so far the guidance documents, which is scientific, quite hefty in size. Then we have the infographic together with the practical guide, which is a very visual presentation of the infographic with a PDF document sitting behind it. And now we have the ECHA manuals. The ECHA manuals are a practical guide for ECHA specifically that tells you there are 3 sections in your dossier. Go to the first, you will see 5 fields. The first field is a pick list option, yes or no, or whatever. It gives you really practical advice how to go through each field and understand what you need to enter in there. And this guide, these manuals, or to be precise, these ECHA manuals are released first when the new version of ECHA is released, and it's usually around April every year. Sometimes it's a bit late in May, but this time was April. So ECHA was released, the new version in April the 27th, and the manuals were released on April the 28th. And also an updated version is released in October. So if we need, if we find some mistake, something is missing, something important that we need to change urgently, we do have the opportunity to update the manual, not to wait until the next version of ECHA, which is going to be next April. We can do it in October. So this is our main sources of guidance, put it as a general term guidance. There is a scientific guidance. In July, in next month, they're going to be updated in a very targeted way. Then there is the practical guide, which will continue to being built up as we're building the infographic, and then the Euclid manuals, which are released every April and every updated, if necessary, every October. We can add this information on our website as well as you suggest to make it clear for those who may not be very familiar with this. I hope my long speech has been of some value. But if this is not clear, please, anyone should come back and ask questions, because it's better for people to show interest about these documents rather than just ignore their existence. Let's move to the next one, which is there an annex available where I can find clear definitions of certain terms, e.g. membrane filter? If you are referring to terms that appear in the legal text, there are, I'm not sure if there is a definition for this in the legal text. It is possible. Usually it's at the beginning of the main articles of the legal text, but I'm not sure if membrane filter is defined somewhere. In the case of the European Positive List, at the beginning of volume 1 of our guidance document, there is an extensive glossary. I suspect, without remembering clearly right now, I do not think membrane filter is something we have addressed because it is not really within the scope of applications for Article 11. So every legal text has its own definitions, maybe may not cover absolutely everything. So you need to go through the directive itself and also the implementing legislation like decisions 365, 367, and regulation 369. And for our needs, to help people understand our guidance volume 1 has a glossary at the beginning. I'm not sure there is one annex. I'm not clear if the Commission has created any such list of definitions. Maybe it's something we can inquire at the Commission. I'll take the next one as well. What are the contact details for testing laboratories that aim to create a migration dossier and have further questions regarding the acceptance criteria that are beyond ECHA's guidance documents? Okay, we recommend, and Nico I think touched already upon this, that applicants use laboratories accredited according to ISO 17025 with an accreditation scope that covers the relevant migration tests. Accreditation of migration testing laboratories will further support meeting the subsequent legal requirements for product certification, and will really support the Committee for Risk Assessment to know that the migration test results you are presenting to them is obviously of good quality. So on the base of this, the quick answer to your question, because I tend to talk too much, is we don't have a list of contact details. I think let's start from that. We don't have a list that we can provide. But what I'm trying to say to help in my unhelpful response is that we recommend that you use laboratories that have been accredited. There are accreditation bodies in each member state. Each accreditation body has a database of accredited laboratories. In many cases, maybe all, I'm not entirely sure because I have not really visited all their websites. In many cases, I have visited many accreditation bodies in different member states. There's a database online. You can search by the standard you have an interest in, that you want to do migration testing according to standard XYZ. So you may find that there are 3, 2, 1, 5 laboratories in that territory where they are accredited to do testing according to that standard, in standard XYZ. So we do not have laboratory contact details ourselves, and I don't think it would be appropriate for us to promote perhaps, but accreditation bodies would be able to help. Let's move to the next one. With reference to the 4MSI list, copper zinc 10 and copper zinc 33 are listed in the European Positive List. After 2021, copper zinc 15 and 20 were added to the 4MSI list. Are all test reports required for inclusion in the European Positive List, or is it sufficient to attach UBA's statement regarding the inclusion of these materials in the 4MSI list? That's a good question. You do need to include the test results. It is not sufficient to simply say UBA has given us an approval. So you do need to present the test results. Of course, if they have done according to the relevant standard, which I anticipate they have been done, you are in a very good place to have a successful application, but you do need to provide a full application. It is not simply to say, please ask Uber, and Uber will tell you that our application back in 2023 or whenever was good enough. Yes, it's a full application. The next message is, I would like to thank you. The WD will be a huge improvement and a very relevant one. Thank you. We'll try our best. I hope what we do is useful, relevant. I will probably pass this on to Nico, judging from the early bits that says about migration tests. I will read it out. Migration test is based on final articles with a shape, right? A substance in EUPL supplied by supplier A to a user B who makes a polymer. The polymer is used by formulator C to make a formulation coating paint to supply to pipe manufacturer D. Who is responsible to submit the Euclid dossier? Actually, perhaps I could take it myself. Yeah, do you want to take it, Nico? Please.
Maybe I'll say something and then you can conclude on that. So, yeah, this is more a regulatory question. So anyone who wants to use a substance in drinking water contact materials, well, it needs to be on the list. So I think they could all be responsible for applying, or they could all do it. So that's my answer.
Thank you, Nico. And the practical guide, actually, that I mentioned, that the one that sits behind the infographic, does address this. The important point is what Nico said. It needs to be on the list to be able to be used. There is no specific responsibility on a specific actor. Anybody, any of these people that you mentioned, supplier A, B, C, D, can act. The ideal would be for these organizations, these companies, to collaborate, because maybe they have different pieces of information. Somebody has more toxicological data, another person knows about the uses, and so forth. So collaboration is the ideal. But in principle, anybody can make the application. It doesn't really matter, and it certainly doesn't matter to us, as long as the relevant, the necessary information is there. So if it is the supplier or the final user, it's really up to the market to decide who is the best placed or willing to put the effort in to make the application. And one that is last, I see now, are the substances which have been transferred from Regulation 10 of 2011, also subject to the same opinions as the plastics regulation. For example, salts have been accepted if the relevant acid is listed in the UPL, sodium sulfate is listed under sulfuric acid. Yes, this is correct. This provision where the salts, named specific salts of listed acids, phenols, and alcohols, also being covered by the approval of the individual acid, phenol, and alcohol, has been taken over. It's one of the notes under in annexes 1 and 3 of decision 367 for organic and cementitious materials. If you go into these annexes under the tables with a positive list, and they're very long, of course, there is a list of notes. In the notes, you will find out that this indeed happens, and there are 17 named salts there. From memory, I'll just throw some names around because I don't remember the full list. Is the aluminum, ammonium, copper, whatever salts, they are named, and these salts of listed acids and alcohols and phenols are also approved. So that means, and effectively, that if you apply for the acid, you effectively approve or continue with the approval of those 17 named salts. Take a look at the note under the EUPL tables, annexes 1 and 3. And that was the last question we had on our list. We have finished a little bit earlier than we anticipated. We'll give people a little bit of time. Maybe there's some late question coming in, somebody who would like to pick up on any of our answers. But if in a couple of minutes we see that there are no more questions, we can finish a little bit earlier. And in the meantime, while we're waiting, I'm being told that in the slide widget that you can see on the event page and also through the QR code. You are also able right now to go into the feedback form. Maybe actually we see something on the screen, I suspect right now, where you can answer a few questions about the event. Now, the event continues tomorrow. Hopefully, even if you don't have a very positive review of you today, you will change your mind tomorrow. So you may wait with your feedback until tomorrow, but if you are not able to participate tomorrow, maybe you would like to give your feedback right now as well. There is actually a new question that has arrived. There is not a SIF like Reach, so collaboration is real challenging. This, I must say, is not a question, it's a statement. But yes, you're correct. There is no such thing mandated by the legal text. This is a known issue. The Commission has been made aware of this. We know that many stakeholders have raised this issue. Indeed, the collaboration depends on your own efforts. It's up to you to consider whether you want to collaborate, whom to collaborate with, to share data, costs, efforts, and so forth. From our side, I know we cannot really be too relaxed about it in the sense that it will affect the way we work at ECHA, but whether you are able to collaborate or not, and we don't want to minimize the challenge. But consider at the end of the day, if a substance needs to be on the positive list, somebody needs to make an application. If it's missing from the list, somebody needs to try to add it. If it has an expiry date that is coming up and you want to continue using it into the future, somebody needs to make an application. So somebody needs to take the initiative, and it is not going to be us who indicate who has to do what. There's another question that came up while I was responding to this one. How are substances which are food additives handled if they aren't listed in the European positive list? For example, monosodium glutamate, I suspect. Are they used as starting substances in drinking water contact materials? Because the European positive list is for starting substances, composition, and constituents for materials that come into contact with drinking water. If taking this as an example, it is used, and I have no idea, but somehow I find it a bit strange that monosodium glutamate would be a starting substance. If it is used and meets the requirements in the Drinking Water Directive legislation, then needs to be in the positive list. But there's no immediate conveyor belt between food additives and drinking water contact materials. Maybe I don't understand the question, but if there's some feedback or quick follow up on this, I'm happy to read it out and see if I can understand a bit better. We seen, yes, there is something. And one more question. I understood that metals that have been added to the 4-member state list after publication of the European positive list need the full dossier. What about the ECHA assessment? Will there be a shortcut since the materials have already been evaluated? That's a fair question. The quick answer is no. We're gonna do a proper assessment like it should be to be obviously fair to all applicants. We cannot really simply say you have applied in the past, you can come through very easily. We honestly expect somebody who has submitted an application to UBA, for example, in the past, to be in a very good shape to prepare an application under the new regulatory regime. And because you have already materials and information and test results, you're gonna perhaps have an easier ride. No, maybe it's not the politically correct word to say, but it will be easier for RAG to reach a conclusion and be convinced that you can use this metallic composition will be used safely. So it does make a difference. We cannot pretend that it does not make a difference. You have already materials in your hands. You have already test results that take, for example, 6 months, and they're already there for you. Other people may start now to start thinking of how to do the migration test results for a new metallic composition, but you still need to provide a full dossier. We're going to do a full assessment. The other thing you need to consider is that, and consider it carefully, that although the main elements of an application for the European positive list are more or less the same with what the 4MSI was doing for metallic compositions, the information requirements do differ, and they're much more demanding in the case of a European positive list application. So it is not a simple matter of saying, I have done everything with UBA, it will be 1 week's job to try to put together an application in Euclid. Unfortunately, it may not be the case. You need to do it carefully. You need to look into the legal text for the Drinking Water Directive and provide the necessary information. And I think there was a question before that we have answered. It is not simply good enough to attach some files from the previous application and think, okay, an empty Euclid dossier with a couple of attachments will do the job. It will not do the job. You will fail validation rules probably, and you will not have enough information to do our assessment properly. So you have a good starting point, but you do need to do it properly. And from our side, we need to do the assessment properly as well. Okay, so somebody came back with the monosodium glutamate to educate me that monosodium glutamate is present in a final polymer composition at approximately 7 to 8%. And this is used in drinking water contact materials. If it is in such concentrations and in the starting substance, then I guess it does fall under the provisions of the Drinking Water Directive contact materials legislation. I have no knowledge of the, as you can tell, obviously, about monosodium glutamate, and the legislation doesn't say anything about food additives. If it's a starting substance and it is present above certain concentrations that you can see in Annex 1 of Decision 365 of 2024, then it may need to be on the positive list. How are substances? Yeah, okay. I think it's the same question as well. Sorry. I hope this is clear. We would be happy to receive, and more generally for everyone, not only for the person who's asking this question. If you want to ask a more detailed question, to provide some additional information, which perhaps you don't want to share with third parties, it's always okay to come to our help desk and provide, ask your question, and then we can provide a response. Sometimes we do need to refer people to the commission because sometimes we are not the right people to answer, but do take the opportunity to come to our help desk and ask questions in more detail if this quick exchange we're having now is not sufficient. It's 4 o'clock. We see no more questions right now. And even if there are any and we fail to address them right now, we'll pick them up tomorrow. So it's not a problem. Thank you for your participation today. We will start tomorrow. Let me check the timeline. Again, it's 10 o'clock our time, so 9 o'clock CET. We're going to go through the very important parts tomorrow: migration, toxicological properties. We have analytical methods, also very important. We have 2 Q&A sessions planned for tomorrow. Of course, we do appreciate that many of the questions were not Euclid related. We would like to have focused on Euclid, but any question will be welcome, and we'll try to do our best to answer. Thank you all, and hopefully we'll see you tomorrow. Thank you.